Today's session is Dr. Lakshmi. She is a research expert, Instituta de Alta Investigation, Chile. Her achievements: she has won the Best Paper Presentation Award in International Conference on Advance in Mathematical Science held at VIT and awarded OTC level state level scholarship in the year 2015-16. She has attended the PhD Mobility program in Malaysia and she has worked as a guest lecturer in Bangalore University and worked as a guest faculty in mathematics at University of Visvesvaraya College of Engineering, Bangalore. And she worked as an assistant professor in Visvesvaraya Institute of Technology and worked as an assistant professor in Sri Venkateswara College of Engineering, Bangalore. And she worked as a lecturer in GSS Institute of Technology, Bangalore. To her credit, she has published many papers in international journals and attended many workshops and conferences. With this brief introduction, I invite you, ma'am. Now the stage is yours.
Thank you very much for the nice introduction, ma'am. A very good morning, everyone. Actually, my topic is linear and nonlinear stability analysis in cylindrical and rectangular geometries. Since many audience are students, so I diluted the presentation and I'm discussing on the basics things and linear stability. So first I'll start with the main content of the paper, of our discussion is Darcy-Bernard convection in cylindrical and rectangular geometry. So before starting into Darcy-Bernard convection, first I'll discuss what is convection, then Rayleigh-Bernard convection, then I'll come to Darcy-Bernard convection, so that you all understand better. So I think convection, all of you know that, right? So it is a way of transferring heat. It's one of the kind of kind of transferring heat. So generally there are three ways. What are the three ways of transferring heat from one system to another? What is the three ways? Yes, conduction, convection, and then radiation. Okay, so our main focus is on the convection. So generally, whenever we wanted to heat any system, like in general case, like when we wanted to boil, whenever we wanted to heat up some water, generally what we see is whenever we give heat, do you see any fluid particle starts moving all of a sudden? No, right? So first, still even the fluid particles is not moving. We can see that the fluid particles gets heated up. So in which form it got transferred?
Gas.
In conduction form, right? So even the fluid particles is not moving, and the one fluid layer gets a lot of energy at the bottom, and then it's transferred to the next level, next layer of fluid. So that way the heat will be transferred. That is termed as conduction. Similarly, convection means the lower part, whenever the lower plate is heated, the fluid particles near the lower plate gets energy and it will become lighter. So generally lighter particles will have a have greater energy and it start moving upwards. Okay, so there the dense particles will be present and it starts moving downwards. So the same thing continues so that the convection cells form. Okay, so that is what convection is. Convection is. Now coming to Rayleigh-Bénard convection. Rayleigh-Bénard convection means whenever the lower plate is heated and then upper plate is cooled, then the fluid particles moves upwards and the denser particles comes down. That process is termed as a Rayleigh-Bénard convection. We can see this kind of a convection in nature, like Earth's atmosphere. The first work, uh, not the first work, it is a one of the example of a Rayleigh-Bénard convection is Earth's atmosphere. Whenever sun shines like Earth's surface gets heated up, then the fluid particles like gas particles near the Earth's surface gets more energy and it starts moving upwards. Okay, that forms a convection. That is one of the example of a Rayleigh-Bénard convection. So similarly, even we can see the convection in ocean. Like the Earth's ocean surface gets heated up, and then in that case the kind of convection is different. Like it is a two-component convection. That is termed as a double diffusive convection. So today I am not going to discuss about it. So it is one of the example of natural convection. Okay. So now coming to Darcy-Bénard convection. Darcy-Bénard convection means you know the Rayleigh-Bénard convection now. Okay. Darcy-Bénard convection is when we have a porous medium in the system. Then there are two types of porous medium generally. That is one loosely packed porous medium and another one is densely packed porous medium. So Darcy-Bénard convection is mainly meant to densely packed porous medium. Densely packed and loosely packed, you can assume that. Generally, porous medium means the system having pores in it. For example, you have seen the sponge, right? Sponge. So whenever you dip that sponge into water, some of the water content will be absorbed and present in that sponge. What did it mean? It has pores in it. So in that, water particles will stay. Okay, that is one of the example of a densely packed porous medium. Okay, and also, for example, sand. So whenever we add some salt into that vessel, okay, and if you pour some water, it will hold some water content into it, right? So that is another example of a densely packed porous medium. Okay, so why we need to study this densely packed porous medium now? Like generally we know the normal Rayleigh-Bénard convection is fine. Why we have to study this densely packed porous medium? So the main reason for studying this densely packed porous medium is because of its many applications. Okay, many applications in the sense of I'll first tell you what happens when the system in the system when we have a porous medium. Then I'll talk about the applications. Okay, so whenever we boil some water, it will get heated up fast. In the same system, if we add some salt into it, means saturated, complete when the vessel is fully saturated, means if we add some sand into it and you start boiling it, okay, means if you just start giving heat, is the water gets heated up fast? Fast or slow? What happens? Is it more energy is needed or less energy is sufficient to make a water to get more to boil? More energy, right? So because sand has less thermal conductivity in it. So when we have less thermal conductivity, it acts like a stabilizing factor. Like it needs more energy to get heated up. Okay, so the main application of studying porous medium is because of its stabilizing effect. It has applications in many fields. Like some of the examples are nuclear reactors, thermal insulation system, and thermal storage systems. Okay, in all these examples, porous medium is the and thermal insulation systems as well. In all of these applications, the porous medium has a lot of applications. Okay, so we are studying one of such system, that is Darcy-Bernard convection. Now I'll come to Newtonian liquid. Okay, Newtonian liquid means we can see many kinds of liquids like water, castor oil, coconut oil, and paste, and all of these different kinds of liquids we can see. In that we can categorize it as Newtonian liquids as well as non-Newtonian liquids. Okay, in Newtonian liquids, the viscosity, the stress is directly proportional to strain. Okay, so in a simple way, if I explain it, like if we have a castor oil, okay, and a bowl of castor oil, and you just move like this, means little damping. If you give little damping, is it varies anything on the surface of that castor oil? Little damping. It does not make much difference, right? See, that means it has its own viscosity, large viscosity, so that it will not alter with the less amount of force. It requires more energy to destabilize that, right? So similar way, when we have a water in the bowl and we start moving, okay, then what happens is the surface gets altered very fast compared to castor oil. Why? Because it is thin and it has less viscosity. Okay, so that way Newtonian liquid means stress is directly proportional to speed. Okay, we are studying one such Newtonian liquid. Mainly we are considering water liquid. There are other Newtonian liquids as well: glycerin, ethylene glycol, then water, and all this comes under Newtonian liquids. In this particular analysis, we are considering water. Okay, and then nano liquid. So nano liquid is like the name itself says, nano liquid. So we have a liquid, and in that we are adding some amount of the nano sized particles. What is the nano size? Yes, 10 power minus 9. Okay, so it almost resembles the size of a fluid particles. Okay, so that it will not alter the nature of a water, nature of a liquid. That's the main intention of having a nano-sized particles in it. So now, why we require to consider the nano liquid? Okay, so in many heat transfer applications, generally when we consider, before that, when we heated some metal and if we heated some water, so which one get heat faster?
Water.
Metal, right? Metal gets heat faster. Metal gets heat faster because because the thermal conductivity of metal is very much higher compared to water. Water has less thermal conductivity. But in many applications, we require liquid. We require some liquid in the applications of heat transfer systems. Okay, so we require the liquid form, but we wanted to have a higher thermal conductivity. What we can do means the higher thermal conductivity is required for the heat transfer processes. What we can do is mixing both. Okay, so nanoparticles are the engineered particles, and there are some there is some percentage to add it. So the maximum percentage we can add for a liquid is only 6%. Okay, so that small amount of metal particles will be added into the liquid, so that forms a nano liquid. Okay, so that is what we are studying in this present analysis, means Darcy-Bernard convection in Newtonian liquid as well as nano liquid. In both cylindrical and rectangular enclosure we are considering. So why we require to consider the cylindrical enclosure? So generally the rectangular enclosures is a well-known research topic. Many works have done in rectangular enclosures. Okay, and cylindrical works are there, but with the very less analytical works are there. Why it is? Because yesterday Pradeep sir mentioned, like when we have a differential equation with constant coefficients, then we can handle that mathematically. Easily we can handle it, right? So when we come to cylindrical coordinate system, you are already studied the special functions, right? What are the special functions? like a Bessel function, Legendre's function. All of this you are familiar with it, right? So whenever we are handling a cylindrical coordinate system, we come across the differential equation with variable coefficient. Okay, so mainly the variable coefficient means the differential equation we get is the Bessel's differential equation. So what is the Bessel differential equation? So anyway, when we consider the rectangular system, the second order differential equation will gives us the sine and cosine function as a solution. Okay, and then whenever we consider the Bessel, the cylindrical coordinate system, we get a Bessel's differential equation. In that, we have a damping term that is dy by dx, 1 by r times of dy by dr. Means I think you remember that. That's why I'm telling this. Okay, so we have a damping term in it. So that the function we get the solution as a Bessel function, and it's due to that damping force, the periodicity and also periodicity will not observe in the case of a Bessel function, and the amplitude is decreased. Okay, that's why it is little difficult to handle in cylindrical geometry, but we consider that case. And then we combine both cylindrical and rectangular enclosure. It's a unified analysis. We can do that. I'll tell you how to do it. So the consideration of cylindrical geometry, really Darcy-Bernard convection in cylindrical geometry is due to its many applications, like the insulation of high temperature, gas-cooled reactor measures and others. So that we considered that. And then these are few references. Okay, in the first part of the discussion, I'm going to discuss about the Darcy-Bernard convection in cylindrical enclosure first, and then we move on to discuss about the cylindrical annuli. Okay, annuli means first we discuss on cylindrical enclosure, and then we consider the effect of insertion of a concentric cylinder into the hollow cylinder. Okay, that forms the annular region. Whenever we insert some smaller cylinder concentrically into the hollow cylinder, that forms the annular region. So we are discussing what will be the what happens in the stability when we have inserted a solid cylinder into that. Okay. Here we consider 4 different types of enclosures. And the equations are modeled for Darcy-Bernard convection in cylindrical geometry using the conservation of mass, momentum, energy, and nanoparticle concentration. And as we know, when we consider the nanoliquid, if we have just a Newtonian liquid, the thermophysical properties are standard. For a water, we have a fixed thermal conductivity, dynamic viscosity, and thermal expansion coefficient, and all of that. Okay, so when we add some nanoparticles into the system, the thermophysical properties will get changed, right? So how to find out that effective thermophysical properties? We require some model to find out that, right? So that can be done using the phenomenological laws. Means the dynamic viscosity and thermal conductivity are found using the phenomenological laws, and the remaining thermophysical properties, effective thermophysical properties, are found from the mixture theory. And even the thermophysical properties gets altered in the presence of a porous medium, that we found using the mixture theory again. And now we come to the standard procedure of non-dimensionalization. So non-dimensionalization means, yesterday Pradeep sir mentioned what is the use of non-dimensionalization. Okay, once again I'm repeating it. So whenever we come across some example, physics example like this, in any example, if they are given if the car is moving in 60 km per hour, to reach some 5,000 km, how much time will take? Okay, it is such questions arises in physics, right? So if you wanted to find out the same, in 5,000 kilometers, to reach 5,000 kilometers, you can find out what is the time. So if the same question will be asked for a 5 kilometers, okay, what will you do? You again have to do the computation, right? Yes or no? You have to do again, you have to apply the formula and find it out. Okay, so instead of that, since it is a general study, we wanted to make it standard. Okay, like even if you consider 1 centimeter, we should have a formula for that. Means that formula should be applied all the way. Okay, even if you have a 1 centimeter, that formula should be applied. And then if you have a 1 meter, then also the formula should be applied like that. Okay, if we don't have a dimension, then the analysis will be general. Okay, that can be done using the non-dimensionalization. Okay, another importance of non-dimensionalization is when we non-dimensionalize the quantities in the set of equations, we come across some of the parameters which represents the physical meaning in it. I'll explain that while getting the non-dimensional parameters. So from that non-dimensional parameters, we can describe the nature of the system. Okay, that's another importance of having a non-dimensional parameters. Okay, so how to do the non-dimensionalization? For example, here we consider the cylindrical coordinates. So R represents the radial coordinate. Okay, so we have a radial coordinate here. One more thing here, all the properties, all the variables are considered in the SI unit. Okay, so that since we are considering SI unit, the radial distance, okay, horizontal distance. What is the SI unit of a length? Meter. Okay, R is in meter, and this R is a meter. I am dividing that with the H. H represents the height of the enclosure. The radial distance is divided by its height of the enclosure. Okay, so what happens is the radial distance is also in meter, and then H, height of the enclosure, is also in a meter. So that the meter and meter gets cancelled, we get the non-dimensional variables. So we use these non-dimensional variables in our analysis. Okay. So after non-dimensionalizing all these quantities, we come across the non-dimensional form of the equation like this. Here we can see this is the continuity equation in cylindrical coordinate system. Not exactly cylindrical coordinate system. In cylindrical coordinate system, this delta value will be 1. Okay. So I have okay, in the continuity equation, we have delta by S into U in cylindrical coordinate system. The value of delta becomes 1. So if we take 0, delta equal to 0, what happens is dou U by dou S plus dou W by dou Z equal to 0. Means this term will not exist. So that gives the continuity equation in rectangular coordinate system. So we are introducing this parameter delta deliberately to switch between the two coordinate system, that is cylindrical coordinate system and the rectangular coordinate system. Okay, so we have deliberately introduced this. 1 and 0 corresponds to the cases of cylindrical and rectangular coordinate system. Similarly, we consider the same condition for delta square, so that this set of equation represents both rectangular and cylindrical coordinate system. Here are the non-dimensional parameters which we obtain on non-dimensionalization. Here RA represents the Rayleigh number. Rayleigh number is the main parameter in our analysis. That can be predicted in many ways. One of the way of predicting Rayleigh number is the non-dimensional temperature. Okay, here this rho represents the density, beta represents the thermal expansion coefficient, K is permeability, then G is acceleration due to gravity, dynamic viscosity, and thermal diffusivity. Okay, and delta T represents the difference between the temperature difference between the plates. Okay, so that on keeping the delta T in the numerator and sending all other terms to the denominator, what happens is it is like we are scaling the temperature. Okay, and then and also non-dimensionalizing it. So Rayleigh number represents the non-dimensional form of a temperature. Okay. And then the governing equations are solved using the boundary conditions, because that includes the differential equation is in terms of a spatial coordinates. So in order to solve that, we need a boundary condition. Okay, here we are discussing on the temperature and the temperature concentration boundary conditions. So the equation 14 represents the lower plate, z equal to 0 represents the lower plate and z equal to 1 represents the upper plate. Z is the vertical coordinate, so z equal to 0 is the lower plate and z equal to 1 is the upper plate, and this condition represents the isothermal boundary condition. What is the isothermal boundary condition? In isothermal boundary condition, there is a exchange of heat between the system and its surroundings. Okay, so whenever there is a exchange of heat between the system and surroundings, we have a isothermal boundary condition. Similarly, the concentration, isoconcentration boundary condition it is. So I mainly focus on temperature boundary condition here. And then at r equal to 0, r naught means r represents the radial coordinate, right? So r equal to 0 and r equal to r naught represents the vertical boundaries. Okay, in that vertical boundaries, we are defining the adiabatic boundary condition. What is adiabatic boundary condition? There is no exchange of heat between the system and its surrounding, so that the first order derivative is 0. Okay, because there is no exchange of temperature there. Okay, so this is the adiabatic boundary condition. We use this in order to solve the equations, and then we arrive at this solution at the basic state. What is a basic state? Generally, when in a convection problems, whenever the temperature is given into the system, the first form of a transfer of heat happens in the form of a conduction. Okay, whenever we give temperature, the first form of heat transfer is conduction, right? And then after sufficient amount of energy, and convection forms. Okay, so then it is necessary to find out the solution at the basic state. Got it? So that at this point we are using means we found the solution, like assuming that the fluid is quiescent. Quiescent means there is no movement of particles, fluid particles. So that we obtain the solution in the form of 16, and after that we perturb the system. Why this perturbation is needed? Because whenever we give small instability to the system, we have to check whether the system is decaying with instability or growing with instability. So if for a small disturbance, if the system is growing its instability, so what kind of system is that? It's uncontrollable instability, right? So yesterday in Pradeep sir talk, they have mentioned that. So we need to study the instability which is controllable. If it is if for a small disturbance, if the system is growing its instability, then the system is completely unstable. Okay, then it is not needed to study such systems. So that the system must be decayed with instability should be decayed with the time. Okay, such systems only will be considered for study. So that we can do by perturbing the system, which that mathematically that condition is given in 17. So with that we obtain the governing equations in this form. So now coming to the linear stability analysis, means in the previous equation we have both linear terms as well as the non-linear terms. So mathematically non-linear stability requires different kind of analysis. Okay, it is not general. There is no direct method to solve the non-linear system. Okay, so that first we consider the linear stability analysis, because the linear stability, the main intention of studying linear stability is because we wanted to consider the point at which the onset of convection occurs. Okay, onset of convection means we already discussed, like first form of heat transfer is conduction, then the convection starts. Okay, we wanted to exactly find out the point at which point the convection starts. Conduction breaks down and the convection starts. That point is necessary to find out in this system. So that point we can find out using the linear stability analysis. So the linear form of equation is given in equation 22. Here there are three variables, that is W, theta and phi. Okay, so it is a coupled system of equations. So in order to solve the solution for a coupled system of equations, what we do is we decouple this system of equation. You are familiar with solving this system of equation. It is in the same way. And decoupling these equations, we arrive at the equations in the form of equation 23 to 25. Okay, it is not in this easy form directly. We need some simplification, rigorous simplification, and we arrive at this kind of equation. Okay, and further simplification of this, this system of equations shall be solved using the boundary condition given in equation number 27. The temperature boundary condition I already explained. W boundary condition is impermeable boundary condition. W equal to 0 means impermeable boundary condition. So impermeable means there is no, the fluid particles cannot go out of the enclosure, that condition. Okay, that fluid is contained in the system. That condition is given as W equal to 0 and U equal to 0. So the linear system of equation can be obtained in the form of equation 28 to 30. Here this del A square plus B into W, that single factor that represents the Helmholtz equation. Since we have a product of two functions here, we considered one of the we considered one of the Helmholtz equation and obtained the solution. This equation del A square plus B equal to 0 will be the Helmholtz equation, and the solution of A is given in equation is given as theta 1. Similarly, the second set of Helmholtz equation gives us the another set of equation. Sorry, another set of solution that is given as theta 2. Okay. So for since it's a linear analysis, one of the solution, if one of the solution is satisfying the differential equation, then it is sufficient. So for simplicity, we consider one of the solution, and also here this J naught represents a Bessel function of first kind, and Y naught is this Bessel function of second kind. And for the considered boundary condition, the coefficient of Y naught B1 becomes 0. Okay, so that we obtain the solution in the simple form as given in equation number 34. Now, substituting the solution in the non-dimensional form of the equation, we arrive at the critical Rayleigh number equation, which is given in the equation number 34. This is the critical Rayleigh number expression. This point, this is the on substituting all of these values into it, then we obtain the value of the Rayleigh number at which the convection occurs. Okay, so this is the way of proceeding to find out the onset of convection. So now we move on to the weakly nonlinear stability analysis. Weakly nonlinear stability analysis. Weakly nonlinear stability analysis, I am not going to concentrate on much. I will move on to the linear stability of a cylindrical annuli part. Okay. So these are the procedures we followed in obtaining this. Yeah, I'll just explain this one. So why we need to do the nonlinear stability analysis? So linear stability analysis we done because we wanted to find out the onset of convection. So at which the convection occurs, we wanted to find it out. That's why you use the linear stability analysis. Similarly, nonlinear stability analysis has to be done to find out the heat transport in the system. Heat transport can be quantified in terms of the Nusselt number. Nusselt number represents the heat transport in the system. Okay, that we can do using the Nusselt number. I have not explained what is how to find out the Nusselt number. I am just explaining it. Okay. So moving on to the results and discussion. Here in the table 1 we tabulated all the thermophysical properties. Okay, so when we come across some parameters like Prandtl number, then Rayleigh number, Navadas number, and all of that, we cannot merely take the values, right? For computation, we require values. Okay, we cannot simply take the values. We for a particular liquid, for a water, and for particular nanoliquid, we can find out what exactly that parameter value represents. Okay, that we can do by considering the actual thermophysical properties. Here we have tabulated all the thermophysical properties, and then using that we found the effective thermophysical properties of water copper nanoliquid. In that nanoliquid, again the shape of the nanoparticles matters. Okay, for this analysis we considered in this analysis we considered 5 different shapes of nanoparticles. Okay, here we tabulated the spherical thermophysical properties of the spherical shaped nanoparticle. Even the shape of the nanoparticles affects the heat transport in the system. This is the thermophysical properties of water saturated porous medium. And then, okay, this is the plot of a Nusselt number for in 3 different values of alpha. Alpha actually represents the volume fraction. Volume fraction nothing but how much concentration of nanoparticles it added to the system. Okay, so what is showing here? For alpha equal to 0, the curve is at the bottom. Okay, as alpha is increasing, means this curve represents the curve of the volume fraction 0.03, and the next will be for the alpha value 0.06. Means whenever we increase the volume fraction, the heat transport curves are increasing. What it means? The addition of nanoparticles in the system increases the heat transport in the system. This is the heat transport curves, right? So that whenever we increase the volume fraction, the heat transport is increasing. And then this is the plot for 4 different types of enclosures. Means 4 different types of enclosure means shallow. First is very shallow, and then square and tall enclosure. And then heat transport is maximum we obtain for the tall enclosure. And then next is the square enclosure, shallow, and then very shallow enclosure. This is the heat transport, thermal conductivity for 5 different shapes of nanoparticles. I have mentioned the the heat transport of the system will be altered by the shape of the nanoparticles also. Why that happen? That because the nanoparticles thermal conductivity is dependent on the shape factor. Means what shape of nanoparticles we consider that affects its thermal conductivity. So thermal conductivity is the major factor in obtaining a heat transfer, right? So that whenever the thermal conductivity increases, heat transport increases. And from this graph we found that thermal conductivity is maximum in the case of a blade shaped nanoparticles. Okay, and the least in the case of a spherical shaped nanoparticles. So the similar pattern we obtain for a heat transport, because thermal conductivity and Nusselt number, the heat transport are relevant. Okay, so the heat transport is maximum in the case of a blade shaped nanoparticles compared to all other shapes. Okay, so next part is we are considering the analysis of a cylindrical annuli. So until now we have studied the heat critical Rayleigh number and the Nusselt number in the case of a cylindrical enclosure. So now we are discussing the effect of concentric insertion of a solid cylinder into the hollow cylinder. So whenever we insert the solid cylinder into the hollow cylinder, then that forms the annular region. So now we are discussing the effect of this onset and heat transport in the case of a cylindrical annuli. So we can do this analysis by just scaling the parameters. Okay, we don't have to do everything from the beginning. By scaling the parameters, like in the case of a cylindrical enclosure, what will be the value of the breadth? So in cylindrical enclosure, we consider the radius, right? R0. If we consider R0 is the radius, then we have a breadth value as R0. So in the cylindrical annuli, what happens? The outer cylinder radius minus inner cylinder radius. That gives the annular region, right? So the breadth value will be considered as like this. Outer cylinder radius minus inner cylinder radius. So this gives us the annular region breadth. So by scaling this parameter, we arrive at the non-dimensional equation in this form. And then following the procedure of linear stability analysis, we obtain the Rayleigh number expression like this. Okay, in the cylindrical enclosure, the solution gives us the Bessel function of second kind, but the corresponding boundary conditions gives the value as 0. Okay, that eliminates the Bessel function of second kind. But in the cylindrical annuli, the Bessel function of second kind also comes in the analysis, and the corresponding dispersion relation we obtain in this form. And following the nonlinear analysis, we obtain the Nusselt number. This is the this represents the equation for a heat transport. And then coming to the results, here we have compared the heat transport in the case of cylindrical annuli and cylindrical enclosure. Okay, so when we consider when we want to consider any two enclosure, it is necessary to consider the same volume of the fluid in the system. Okay, that can be done by considering different. Here we have considered different values of RW and R0 to make sure that we are considering the same volume of fluid in it. Okay, so by this we have plotted the Nusselt number in the case of a cylindrical enclosure and cylindrical annulus. So what happens is, in which case heat transport is more? Annulus case, right? This is the upper curve. So in the case of a cylindrical annulus, the heat transport is more compared to cylindrical enclosure. Okay, that means even if we consider the same volume of fluid in both cylindrical annulus and cylindrical enclosure, we will get we are getting the heat transport is maximum in the case of a cylindrical annulus. What it means? The curvature. What's the reason? The reason for this is, whenever we consider the cylindrical annuli, there are two cylinders in that. Okay, inner cylinder and outer cylinder. So means we have a two curvature effect there. So that curvature effect is to maximize the heat transport. Okay, whenever we consider the more curvature effects, the heat transport is maximum in that case. Okay, and also in here we have considered the cylindrical annulus with the inner cylinder as 0.3 inner cylinder radius, and then another case is inner cylinder radius as 0.2. Means even if we increase the inner cylinder radius, again we are getting the heat transport is maximum in the case of larger inner cylinder. The reason for this is again a curvature effect. If we consider a smaller inner cylinder, the curvature effect is less. Okay, if we increase the inner cylinder radius, what happens? We are getting a larger, we are considering a larger cylinder. So curvature effect is increased. Whenever the curvature effect is increased, heat transport will be maximum. Okay, coming to conclusion. So here we have done the linear and non-linear stability analysis in both cylindrical and cylindrical enclosure and cylindrical annuli, and then by taking the curvature parameter delta as 0, we can arrive at the results of a rectangular enclosure. So that our study is a unified analysis of both cylindrical and rectangular coordinate system. And then effect of concentric insertion is to enhance the heat transport in the system. Means the case of a cylindrical annuli, and then the heat transport in the case of a cylindrical annuli is maximum compared to cylindrical enclosure, and which is compared again to rectangular enclosure. The heat transport is least in the case of a rectangular enclosure because there will be no curvature effect. So whenever the curvature is there, the heat transport will be maximum. And the next is critical Rayleigh number. Critical Rayleigh number represents the onset of convection. convection. So onset of convection advances in the case of a presence of nanoliquid. So this chi represents the volume fraction, which is related to nanoliquid. So that whenever the nanoparticles are present in the system, onset occurs earlier. Okay, so that it enhances the heat transport. And the heat transport is maximum in the case of a tall enclosure compared to all other enclosures. And then compared to 5 different shapes of nanoparticles, heat transport is maximum in the case of a blade-shaped nanoparticles. That's all. These are references. Thank you. Any questions?
Do you have any questions from the audience? Okay, then we can conclude the session. My sincere gratitude to our resource person, Dr. Lakshmi, research expert, who delivered on the topic linear and nonlinear convection in cylindrical geometry. It's really a spectacular session, ma'am, and we are very overwhelmed by your lecture, ma'am, the way you represent.
Thank you.
You have explained all the concepts well with the example, which is very easy for us to understand. Thank you, ma'am. So overall, it was very informative to us. And at the outset, I would like to thank our secretary, principal, and our head of the department, Mr. R. Venkatamanan, for arranging this international conference. Thank you all once again.
Thank you very much for the patience hearing, and I thank the conference organizers for giving me this opportunity to present my to discuss here. Thank you very much.
நான் பின்னாடி போறேன்.
Start your day with a smile because you are lucky to have seen a new day. Good morning to one and all present here. Good morning is not just a greeting. It signifies a hope that the beautiful morning will bring a smile on your face and happiness in your life. On behalf of PG and postgraduate and research department of mathematics, Dwaraka Goverdhan Vaishnav College, I welcome my dear students and participants of various colleges for International Conference on Applied Mathematics and Computing 2023. This session, our resource person is Dr. Nagappan Govindarajan, Professor and Head, Computer Science and Engineering, Savita Engineering College, Chennai. Sir, areas of specialization is Computer Science and Engineering, System Engineering, and Operation Research. Sir, Technical Program Committee member of World Innovations and Computing Congress 2018 held during 2022 to 24 March 2018 at Coimbatore. Remote Center Coordinator for IIT Bombay and IIT Kharagpur NMEICT project. Invited to be a session chair, judge, and to deliver guest lectures at various reputed colleges and universities during various occasions. Sir also guided about 26 PG projects and 48 UG projects. With this brief introduction, I welcome sir. Now I hand over the session to you, sir.
Morning.
Morning, sir.
Good.
Morning, sir.
Good. Thanks for excellent response. I want you to be active. Can I make sure of that?
Yes, sir.
Because time has been reduced to me and I have to complete soon. But I want you to be active. Come on. Take a paper and write down some terms which you have been using, which you observe here. See to various terms here in this word cloud. We will be using lot of technologies every day. Is that right? And I want you to note down some technologies which you observe from this. Anything about it? Come on, be quick. I'll be giving you a lot of activities and those who perform well will get some prize. Okay? Be active. Let us see who writes more technology terms or technology products which you use daily. Which we use daily. Indian. How many? How many you have written? 3? 5? Somebody started using Google.
11.
7?
11.
11? Anybody else? More than that? Hope this is not visible. Let me move to next slide. It is still more visible, right? Come on. Try quick. How many can you write? Come on, I have to talk to you with numbers. Tell me how many you can write? Yes? 20? 22. Okay? Do you accept that all these words are known to you? Yes or no? We use day in and day out, right? Fine. Let me show you. It contains these many words, right? Just see how many they are and what they are. Are we not using them? Yes or no? And this is what we are going to talk about. Alright? Exciting? Yes or no? Yes, sir. And do you know one more thing? Proud to stand before all of you mathematicians of today, tomorrow and every day, because you all people do research for us to implement all this and being given to society. Okay? Proud of you all. Clap for yourself. Okay? And this is what is going to be my discussion. I wanted to talk to you about Industry 5.0, which moves from innovation to intelligence, start to smart, and about Society 5.0, where we live. And it is going to be the change from economic development and solutions to social problems, which is really needed out of our research. And the disruptive technologies, how it is transforming people's lives to more convenient, accessible and efficient. And that is what is the purpose for which we do research. And I wanted to talk to you about the open research problems available along with the United Nations Sustainable Development Goals and about your applied mathematics, which we have been learning. Okay? So what is this Industry 5.0? It's a shift from a focus on economic value to a focus on societal value, and from well-being to, that is, from welfare to well-being. So, have you heard of industrial revolutions? Yes. So, from mechanization, we had 100 years to shift to Industry 2.0 of mass production, electrical power and assembly line, and we had to take up 100 more years to move towards computers, automated production and electronics. But it took only 10 years to move to cyber physical systems, IoT, networking and machine learning. And just imagine how many electronic devices we started using. Even the layman has a phone today, which is a smartphone with camera, right? We cannot imagine, just even before a few years, we had our, what? The film rolls. And now each one of us have our own cameras, and all smartphone has converted all these electronic gadgets into one device, right? So with this industrial revolution, what has happened? So we have arrived at various new such technologies, the technology enablers, and these are going to be the disruptive technologies which are replacing everything whatever we are using, right? So it may be AI, integration systems, big data, cloud, 5G, 6G and what other G comes, extended reality, right? So you must be playing games, you must be driving your own vehicles even without physically sitting on the vehicle. You can train anything, and you have IoT even without knowing that you are being in a place, you are using a device, you are being monitored and you are performing activities. And all these robots and drones are occupying all of our space, and we talk about cyber security in each and every digital transaction which we perform, and the simulation softwares and additive manufacturing which can even manufacture anything, which can even design anything whatever you want, including food. Okay? So we concentrate on human centricity, specific to you, more concentrated on human needs beyond wants, and it has to be resilient. Even if it fails, it has to come back, right? And it has to be following the sustainability in the world for the human life to persist. Okay? So with all these technologies, we connected. Let me ask you something, right? For example, you are standing to cross a busy road, all right? And in that case, what is being applied there? What do? You see the vehicle, you just stand there, you see the vehicle coming that side, you see the vehicle coming this side, and you require to calculate how much time it takes for the vehicle to, or those vehicles to come to your place, and you have to see how fast you are going to cross the road, and how much time it will take for you to cross the road, alright, and whether it will, what is the time at which you have to start in order to cross the road so that you will not be hit by any car or anything. Okay, no accident will occur. So if this is going to be the situation, you perform a complex partial differential equation and you get the result over there. That happens within seconds and you don't know that you do that. Alright? And if you don't believe that, you try to design a robot which will cross the road. Okay? And obviously you have to apply partial differential equation in order to make the robot without accident. Alright? So all mathematics is within us and we perform that even without knowing. And let me ask you a question. You go to a pizza shop and you order for a large pizza, okay? And it costs around 200. And the person says, sir, sorry, large pizza is not available. Let me give you 2 medium-sized pizzas. It costs around 150. I will give you 2 medium-sized pizzas, but I will charge you only 200. Fine. Will you accept or not? No? Why? Why? Why we should not accept? Good. But not everybody will think. Since you are mathematicians, you will think, right? Otherwise, they will think, okay, it is 150 plus 150, 300. Instead of that, I get it for 200. Right? Let me buy. That's what will be the mentality of a person. But large pizza, the radius would be maybe 6, right? And the medium-sized pizza will have radius of 4, right? So if you calculate the area, it's going to be even, that is with radius of 6, it would be much more higher than 2 medium-sized pizzas. Okay? And we should know the formula of area. You apply it, you get the radius, you calculate, and you require to this, right? And let us think, how does, for example, if I start to, as computer science engineer, when you try to apply all such mathematics, where at all it comes. For example, if there is an automatic door which has to be designed, then do I require to think about the logic of designing or not? So, well, I should decide where to place the sensor, whether the person has to, if a person comes, the door has to open, and which side it has to open. If it is going to open that side, I should also have a sensor on that side, whether there is another person standing over there. Okay? If there is no other person, then it can open. And how long it should be open? Then again it has to close, right? Since it's an automatic door. And if there are persons on both the sides, then how should it be opened? Who has to wait? What instruction has to be given? Just think it's not so easy automating everything, right? And all this requires logic and mathematics, and that is where we work. Let us take example of a vending machine. Even a small vending machine requires to check a coffee vending machine, right? Imagine it has to check whether sugar is there, powder is there, the cup is there, and the level of heat, the heater is working or not, right? All these things requires logic, sensing, and the mathematics is involved in all this. Let us take, let me give you one problem. You know weighing machine? Yes? Fine. So you will have 2 plates with which you will weigh, and imagine there are 9 coins or 5 coins, okay? And one of them is defective. All right, that will weigh less than the normal weight of the coin. Okay, I want you to find out which coin is defective. You don't know which coin among the 5 is defective. So how many times you will weigh in order to select the defective coin? Just think. Yes? 5 coins are there, one is defective. How will you find? Louder. You have to answer me louder, else how can we discuss? How many times we have to weigh?
4, sir.
4 times. How? Replacing one. So first coin you will put in one plate, another coin in another plate, you will weigh, and if they are equal, you will keep aside, again you will take next one. If one is weighing less, then you will choose that one and give it, right? You will use 4 times you will weigh. That's what you say. Let me say you say 3 times. Can somebody do less than that? Yes? How? Okay. 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 So that is, but what in case if both of them are equal? Right? So you should think of keeping one coin aside. Okay? So keeping something outside and you require to compare the remaining 2. Fine. What in case of 9 coins? How many weighings you require?
2 times. Same. 3, 3, 3.
3, 3. Okay. 3, 3, 3.
3 in the other side, 3 in the other side. They'll be equal if one coin is defected, sir.
Yes, only one coin is defective.
So they'll be equal.
Okay.
So now,
You will have 3 more coins.
yeah, I'll be so that defective coin will be established in some way.
See, that's one way. What about keeping 4 and 4 and 1 coin outside? Right? So 4 and 4. How many steps it will take? How many steps it will take? It will take 3 steps. Right? So this here, if you take 2, 2 and that is 3, 3, 3, then what is that is right? Okay? So you will measure 3 and 3. If there is going to be difference, right? 1 is going to be down, then take only those 3 coins and keep 2 as she mentioned. Keep 2 coins on the way and 1 is going to be outside, and you will decide. With 2 alone you can identify the coin weighing less, right? So all these are logic, and where do you apply that? Sir, you are just saying about coins. How is it related to anything with the industry or something? Yes. So with if there are many defective parts and we require to identify all those things, right? We require to apply all such logic, and these are basic logics really required, right? Not that all equations what you learn are going to be immediately applied in the industry, all right? And let me ask you another question, right? Imagine there are three cooler vending, there is juice vending machines available, and we are going to so there are 3 juice vending machines. One gives Pepsi, one gives cola, okay, only cola, and other machine is going to give you randomly either cola or whatever this, right? So Pepsi. Fine. Now, what happened is each machine will have a sticker saying cola, Pepsi, and random. What the funny boy did, you know, he replaced all the stickers, right? Now, you are going to see, you are allowed to identify which is what, okay? So, how will you be able to identify that, and with how many testing you will be able to do?
2 tests.
2 testing minimum.
Minimum.
How?
When I get 2, I'll automatically know the third one.
See, you know already that this is the first one. This was cola machine, this was Pepsi machine, and this was random machine, right? You know that, but no, you don't require to. You don't know actually what were the machines, and now he has replaced the stickers. You say with 2 times. For example, you will go to the first machine, get the drink, and you will go to the second machine, you will get the drink, and you will know. That's what you say, right?
When you know the 2 machines, you automatically know the third one.
Okay.
When you got a random and Coke, then you know what's Pepsi.
But how will you know it is random? There is going to be something. It may be a cola machine, or it may be some other machine, Pepsi machine. It may be random machine also. Just think. 4 times, sir. 3 times.
First we have to know the
Which is
probability splitting of
Don't think much. With only one testing we can do. Just think, right? Before I finish the session, you can think and say, right? See, have you used passwords? Obviously, we use cryptography, and it is with all mathematics what you learn, right? And have you used Facebooks? They are all using random graphs, all right? And have you seen advertisements in internet? Whatever you get. Just I was talking about pizza to somebody, and I got advertisement on pizza, right? On my wallpaper of my phone, right? All this happens with all this technology. And remember, be careful when you have your mobile phone nearby you, and it is always watching you, hearing you, doing everything. You doesn't know that the camera is on. You doesn't know that the speaker is the mic is hearing you, and business is happening with all this. Okay. And all these technologies are helping for that. So be careful with whatever you do. You are personally monitored everywhere, always. Okay. And there we use non-parametric Bayesian stats and auto tagging in FB. What is auto tagging in FB? You put your photo and it automatically identifies. When you try to tag, it automatically identifies all your friends in the photo and says, this is so and so, shall I tag, shall I tag? What's happening? Right, it's image processing which is applied on your phone, in your photograph, right? And that's what is happening. Even in your phone, in your gallery, the faces are identified from the photo and it is showing you, right? Is it similar? Yes or no? Same person or not? Alright? All these are image processing and with neural networks, convolution neural networks, and it cannot happen without maths. And even maths is applied in food preparation. Okay, so what is the material available, what kind of food, what has to be prepared, what is the proportion for how much people, how much quantity of ingredients have to be applied, all such things. Okay, and even in sports and games, just imagine there is no any sport without any mathematics. Let it be angle in cricket or football or basketball or whatever it is, or game theory in chess and all indoor games, and everywhere mathematics plays the main role, and they don't know that they are using mathematics. And mathematicians can shine in designing automated systems, training systems for all such things. Okay, and just imagine speech recognition without mathematics. So you require to compare, analyze, and say and recognize your speech. All these are latest technologies which are very useful and being used in industry, and all these contain mathematicians. Very good hope for all of you. And business and sales, and even in weather. Alright, this slide I just added in order to give you an idea on how you can involve in all the technologies whatever we are going to just see. Alright, you want to know about how and all you can involve and what are the technologies are there? Yes or no?
Yes.
Right. So we are in Society 5.0. You would have known about Industry 5.0. It's Society 5.0, which is human-centered society, and it balances the economic advancement with resolving the social problems, right? With integration of cyberspace and physical space. All right. So this one. So we were only hunting and gathering. Then we started agriculture, industrial, and information age. And now we are in new society where all these technologies are going to be human-centered. And we will see what is this Society 5.0, right? So, see, in current information society 4.0 we were using, so we had navigation systems which human had to operate, and we have to analyze the information, and the robots produce under the control of human. Okay, so this is how we are, and we have cloud technology. All this we have been using, but with Society 5.0, with AI being introduced, all this, right? So it has the big data which is available. Whatever you talk, whatever you put on Facebook, whatever you do, right? Everything is a data, and that is always available. And AI is there to analyze all this. And what and all it does, automatic driving from navigation. You don't no more require Google Maps. It automatically drives. No more drivers. Car will come, use it, and you can. Okay. And it is going to it is going to replace, so you need not analyze any information. It will give you all the information. Sir, this is what you want, this is what is your temperature, this is what is your sugar level, this is what you have to do, please do that. It is going to tell you what you have to do. Alright? And you have to obey for that since it is analytically proved. And automatic production with robots in factory, it knows what has to be produced, when it has to be did, how it has to be channelized, right? The sensor information, how we are tracked. So there are going to be several sensors, camera is a sensor, mic is a sensor. You have lot of other sensors, I will show you, right? All those things take up the data from you, perceive the data, and what has to be did, all this information, high value added information, proposals, operating instructions comes from AI. Okay? So there is a big boss sitting there doing all this. And all those algorithms you are going to write, we are going to write. Okay? So with IoT, we will see, we had lot of knowledge and information. So here it is going to be new knowledge, sorted knowledge, and it is going to be shared. And in case of elderly, so there were several constraints with people, how they have to be handled and all such. But here it is overcome with, for example, if you want anything, it can be delivered. You don't require many more people with you to support you and so on. There are going to be devices to support you wherever you want and whatever you want. And burdensome work of people with all such information is being converted. So huge information analysis is already performed, and only the result and inference is given to you. And even the large amount of work which was unable to be did by human is being replaced with the robots, cobots, and all such things. Right? So this is what is Society 5.0. If you take example of agriculture, see, it affects all industries. If you take agriculture, just think about the problem where experience is necessary, all such things. So we don't require all such things here. We have market data, we have the trend of food which is being taken, we have the weather data, what has to be planted and so on. We have multi-robot tractors, we have water management bubble and smart farming machines which can do the work for you, no need of human, and we can do stable production and labor saving is also did. Right? This is about your agriculture. Let us go to another industry like food industry or food handling in your house or in stores and so on. So we had allergic substance, what to buy, what not to buy, is it healthy for us or not for individual, and while purchase. So I have this material already, I have bought it again, all such confusions were there, and many unsold materials were there in the store. All such problems are converted with AI and taking up all this information, stock data, market information and so on. So improved food safety, food will contain all the allergy information and all such things. When you see a material, it will say, okay, this is good for your health, this is not, like that it will say, okay, automatically. And you also have reduced base, automatic food stock management. If something is not there in your fridge, IoT the fridge will say to the store will deliver it in your in the drone to your house, and you need not order anything, automatically your bank account will be reduced with the money, right? And comfortable meal, whatever what is your family preference, what is your daily health condition, all these things are monitored. There will be robo which will help you. If you want to add flavor, you can stand there and add whatever you want, right? That's what is going to happen, and you need not worry about all those things. And what about market? So they are going to order and maintain the inventory based on the customer needs. So this is the season, this is the trend, what is the probability, and what will be sold more, right? All those things that will decide and automatically come. And taking about the health, so medical side information we can take, environmental data, medical data is taken, and even sociological data, like you have smartwatches, you have all such devices to monitor you, blood sugar, GPS level, heart rate, body weight, blood pressure, everything comes there, everything is analyzed, and you are having a comfortable living. People, robots will talk to you, tell you, medical assistance and everything, like Google Guttappa movie, whatever you saw, na? Right? And health promotion. So early detection of illness even before the illness actually occurs, and optimal treatment, sharing your data with any doctor, any medical, it is available on cloud, it is always there. And reduction in burden. So your caretaking robots will be available there. They will take care of your health. Coming to energy, with weather information, with EV, electric vehicles and so on, and energy can be interchanged between regions, and hydrogen can be used as fuel, and solar and wind energy will also be taken up, and your energy can be saved and utilized in a proper way. Okay, so in health, in energy, or in case of production industry, in case of agriculture, in all these places, the comfort part, green layer is being added, and that's what is the advantage of Society 5.0, and it gives us comfort, vitality, and high quality life, right? Everyday life is happy and fun, and benefits everyone regardless of age and gender, and operated with cumbersome work, efficiently utilizing the time, so you need not waste your time sending your data, searching for files and all such things. Automatically whatever you want, you need not even open your mouth and ask, right? You need not search anything, you need not you just think and it will happen. Okay, and you need not even think also, it will automatically say, sir, you are being monitored, you have to be given this one, please take this tablet, it will automatically, your BP is raised, your sugar is level less, please have this, right? It will come and put in my mouth, pour water and go, right? So, and high quality living with more convenient, safe and secure life. See, just remember, with all automated cars and all such things, there won't be any accidents and all other such things, right? We will be much more safe. And for designing such system, we require all such disruptive technologies, right? So these are the society where we want to live. It's just like imagination, where we dream of, fine. But without these technologies, these dreams have not become into reality, right? What are those disruptive technologies? And they are disruptive because they are entirely replacing what is the technology today, right? So every day it changes, that's why they are disruptive. Anything will be changed. How do they change? So they disrupt our communication with what? Social media, messaging app and video conferencing and all such things. Just imagine how you are learning during your COVID. Alright? You would be in your school or in the first year of your college, right? So we would not have imagined sitting in house and listening to class, or your parents sitting with you and listening to your class, right? Both the things. And in work, so with automation, AI, internet, people started working remotely from wherever they are, and they are able to communicate and interact with everyone and do their work so easily and in efficient and effective way. Healthcare, again telemedicine, wearable devices. I've heard of wearable devices. So a small stud, it need not be a device which is with you, right? So your hearing machines or your sensors can be like your jewelry or a watch or all such things, right? But they are made. Anybody doesn't know that you are medically unfit. There are devices which are there. So a glass or a pendant or a pen or all such things or wearables, even your dress can be there, which can be your sensor. Okay, and even in education with online platforms and transportation, even you have your drones which can take you from one place and drop you at another. Right? You would have heard of IIT released a taxi, right? Have you heard of that? IIT Madras has a taxi which costs just 6 times higher than auto fare. But that doesn't matter. It will take you from any place in Chennai to any other place in Chennai within few minutes. Alright? It will come to, if you book for it, it will come to your terrace. You can go and sit in it. You can go to the place wherever you want within few minutes. Just 6 times of what you pay. Like a helicopter, it will take you. It is on. You can search and get it. Okay? And what are those technologies? AI and ML, okay? And blockchain, Internet of Things, augmented and virtual reality, quantum computing, cloud computing, collaborative robots and additive manufacturing. Right? This is what I want to show. And while I am showing, I am going to show you not just about the technology, But what are the things in case you want to involve yourself in these technologies, right? Don't worry, you are mathematicians. You cannot learn about these things. It's not like that. It's open for all because we are all using it. You can also learn it, and you require to learn. And once you learn where you can learn, what will be the salary, which are the companies employing you, all those I will be showing you. Interested to see that? Yes or no?
Yes, sir.
Right. So first one is about AI and ML, and it is very much useful in manufacturing process, supply chain management, reducing waste, improving product quality, efficiency increase, right? Everything. And it doesn't require anything else other than a fast computer with high RAM and a dedicated graphics card. And you require to know about Python, TensorFlow, Keras, PyTorch. I tell you in detail, right? So if these are there, you can be an AI and ML expert. Alright? But so these are the applications wherein you use predictive maintenance, quality control, supply chain optimization, and smart factories. Can be with applications of AI and ML. And what are the tools which are being used? So Google gives Google Cloud Platform and TensorFlow and Cloud Auto ML, right? Amazon also does with Amazon SageMaker and Amazon Recognition. Microsoft does with Azure Machine Learning and Cognitive Services. See, all the top companies are investing on AI ML, and you can learn all this. I'll show you the courses as well. If you learn, and you are going to earn. And this IBM does it with Watson Studio and IBM Cloud Pack for data, and NVIDIA does it with GPUs and CUDA. Okay? And if you see, where can I learn? Yes. So these are the courses available on Coursera, Google, MIT, and Microsoft AI School. And the courses which I am showing, most of them are free. Okay? They are free. And in case if they are paid, you can also get scholarship for that. Alright? They are available online. And you can, even if they are paid, those courses will be very valuable. Once you have got this certification, immediately you will be paid, and you can join with the salary of the entry level average salary for AI ML engineer is $78,000 per year. Okay? And even in India, it is almost equal. I am talking about all countries. I am saying global salary. Right? What are the skills you require? Strong analytical and quantitative skills, which you already have as mathematicians, and proficiency in data analysis tools such as SQL, Excel, Python, R, which you can easily learn. Learn Python, that is so easy. How many of you know Python? Very good. See, in engineering, we started, we asked our mathematicians where do they really apply. Okay? And they said something. And then we started combining what mathematics is required and for which engineer. That topics we started teaching them and started implementing them in Python also. So mathematics teachers started learning Python, and our engineering teachers started knowing complete mathematics of what really they use. So that's what is the merger which is happening, and you people start learning Python. It is so easy for common man, and it is also free, right? And the various job roles are like AI engineer, ML engineer, data scientist, data analyst, deep learning engineer. You are all very much fitted for all these, just with the flavor of AI ML. Okay? Next. So next is blockchain technology. This is very much dealing with security and supply chain, finance part. And here no special hardware is required. You require a better computer and internet connection. That's enough. You require to learn about Ethereum, Hyperledger, and Corda. And the language, main language which is used is Solidity or Go. Go language is a programming language introduced by Google. You know that? No? Please note down. Solidity, if you learn, you can earn much more in stock exchange and all such things. This is much more related to finance, right? And it deals with supply chain transparency, digital identity, smart contracts, and decentralized manufacturing. Okay? And IBM, Microsoft, SAP, Oracle, Ripple, all these people are investing on this, and tools are available, and most of them are also free. Okay, I have brought all this data to you just for making you to involved in the latest technologies along with your excellent mathematical skills. Okay, and these are the places where you can learn about blockchain. IBM has a course on it. Coursera, edX would be paid, and B9 Labs, Ethereum themselves have given this course. Don't worry, I will share this PPT with sir. You can also refer all these and learn. And the skills required are again solidity and grow, and experience on this frameworks, Ethereum, Hyperledger and all, you can learn there. And you can be blockchain developer, smart contract developer, blockchain engineer and solution architect, right? And the starting entry level salary will be $70,000 per year. Okay, next is Internet of Things. Okay, so you have IoT enabled homes, IoT enabled cities, airplanes, that is trains. You have IoT enabled factories, stations, devices and so on. And you have lot of sensors which are working for you, and Amazon, Google Cloud, IoT, all these people are working for that. And it also helps in various applications with smart products. And all I am sure all of you have IoT based devices in your house, right? When you say Alexa do this, Alexa call, okay, automatically it is IoT, right? You use your smartphone, it's IoT. And Cisco, Siemens, IBM, Microsoft and Amazon, all these people are giving up their own tools for IoT. And see, even drones are based on IoTs. You know how drones are useful? We have been using it for only marriages to take videographs, right? That's what is the only thing we use nowadays. But actually it is being used in emergency purposes, in agriculture, farming, even pesticides, right? And delivery services in Amazon and UPS and all, and infrastructure inspections where man cannot go and do, entertainment, and for military and defense also. So you can see in military and defense and pesticides, selective area it will select where is the plant, that place alone it will throw the pesticides, right? And smart homes are there, and even in destruction and all other places to lift people and other things. And where can I learn about IoT? So these are the courses available: Coursera, Udacity, edX, IBM, and pay scale. You see, it is right. It's 1,02,030. That is $375 per year. Okay. You have several job roles in this, and you require to learn about Raspberry Pi, Arduino, and the protocols for that. You would have heard of Raspberry Pi, Arduino. Right. It's simple programming with hardware. And next is augmented and virtual reality. We have been using this for playing games. Xbox games. But actually it can be useful for many such things. Alright. So, and you require a high-end graphics card, fast processor, plenty of RAM. But other than that, the benefits are higher. Unity, Unreal Engine, the software. Game development பண்ணலாம் மெயினா AR kit, AR core. So எங்கெல்லாம் யூஸ் பண்றாங்க பாருங்க, டூரிசம். நீ எங்கேயுமே போகவே தேவையில்ல. AR kit இருந்ததுன்னா வீட்ல இருந்து அமெரிக்கா போயிடலாம், ஜப்பான் போயிடலாம், பிரான்ஸ் போயிடலாம், திருப்பதி போயிடலாம், எல்லாமே பண்ணிடலாம். Right? So you can visit and enjoy. You can also have devices connected to you. அதே இதுல ஃபார் எக்ஸாம்பிள் ஒரு ஃளைட்ல பறந்தோம்னா இல்ல ஒரு ஃபால்ஸ்ல போய் குளிச்சனா என்ன எஃபெக்ட் இருக்குமோ அதே எஃபெக்ட் உங்களுக்கு வரும். ரைட்? குளிரும், எல்லாமே பண்ணும். And in civil construction, all such things, even you put without constructing a building, you can without constructing a factory, you can construct it. Actually, you can walk around and see, keep the furniture, keep the devices wherever you want, right? And you can feel, and then if you accept, then you can really build the building. And in healthcare, even you are able to, even without touching the person, you can really sense, go inside him, right, and see what are the parts which are defective. You need not do any scan or anything. With AR, VR, you can just do. And in case of education in all these fields, it is also useful. Doctors, without even a dead body, they can really learn about all the body parts, how it functions, how blood flows, or whatever it is, right? and these are the application in training. For example, even without a flight, see if somebody wants to be a pilot and drive a flight, right? Can we give a flight to him initially and ask him? Then a cycle, so you can give him AR/VR, he will sit as if he is sitting in a flight, he will drive, different situations will be given. You can learn that. Once you are ready for that, then you will be allowed in a flight. Right? Like that, such factory situations and all such things, training happen with that, and maintenance of several devices, design and prototyping, which can be good in 3D printing, it can be printed, remote collaboration can be, see sitting here, I can talk with Prime Minister, right? I shake hand with him and do anything, right? He will talk from there, we can interact, right? Virtual conferences and so on. So here, Microsoft, Magic Leap, Unity, Oculus and Google, all these people are working on it, and these are our global partners. Average salary, starting salary 10 lakh per annum. Okay, just this is about in India. I will show you in case of global salary, starting salary is $1,20,000 per year. Okay, and the skills required are just to see your problem solving skills, C++, C Sharp. Right, these things are required. You are mathematicians, good problem solvers, right? And you have courses on all this, you can learn, and these are the job roles. Next is quantum computing, right? And you can see even Google CEO is just, you know his name? Sundar. Good. So they are also working on it, and we have very few people working on it like IBM, Google, Microsoft, and not everybody can work on it. But anyway, if you are interested in quantum, right, quantum physics, you can involve in this, and that is going to, see, note down, quantum is going to rule the world in few years. Okay, if you involve as mathematician in quantum computing, then you are going to be very much useful to the society. So in material simulation, supply chain optimization, pattern recognition and optimization, and IBM, Google, Microsoft, Rigetti Computing, Honeywell, right? So all these people are creating quantum platforms and sources. Here you can learn the fundamental courses only. We are not much exposed to quantum now itself, right? Because there is much more to explore. Job roles are there, physicist, computer scientist, right? And engineers, and average salary, you can see, right? It is much more higher. Cloud computing, already we are into it. People started using it. If you have a Google ID, then you are already using cloud. Alright, simply. And what cloud does? Smart ambulance, smart security, smart traffic, smart transport, smart farm, environmental sensor, air cleaner, clean energy, water, right? Smart parking, everything is smart now. Why are we not smart? Okay, we require to adapt to all this. Collaborative robots, it is replacing the complete industry. Okay, whether it is food and beverage, or it is pharmacy, or it is manufacturing, all these things are programmed and automatically performed. You need not do anything with human, right? And they perceive your human requirements, and it is designing, customizing everything for you. And there are global partners for it, and average salary for the entry level is this much, right? And additive manufacturing called 3D printing. Have you heard of it? Right? So it is replacing everything with the various materials. For example, if you stand, the 3D image of you can be created, and immediately you can be printed. Your life-size model can be created immediately, right, with 3D printer, and with all such material, plastic, powder, resin, metal, and all such things, and the metal are being used. So what are the places in automotive industry, machinery, special medical implants like dental and other things, robotics, handling robotics, lifestyle, sports, custom parts. For example, you drive a car, and in between there is a breakdown because of some wheel, there is a part which is broken. Okay, you manage, see, automatically the IM car will communicate it to the nearby that is the service center, and before you reach that service center, the service center will get the parts, what part is damaged, and that your original equipment manufacturer will give them the 3D model of that part, and that will be printed in 3D printer, and that will be kept ready, because once they order that one, it has to come 1 week, it will happen in your own service center. But nowadays it is being printed in 3D printer and it is kept ready, and once you reach the place, immediately the service center person will fix it and you can continue your travel, right? So that is how it is. Okay, and a heart, even your that is surgical devices, medical implants, including your tooth, right, heart, and all such things are being printed in aerospace industry, art and design, even construction, 3D printed houses, right, which can withstand all such things, all such calamities are being constructed so quick. In healthcare, in manufacturing industry, architecture and construction, education, art and design, and even in food. So food is also being printed in whatever way you want, whatever shape you want, whatever flavor. You need not cook anything. You say the 3D printer will cook your food and that will be ready for you to eat. Okay. So these are the global partners, and the average salary which you can get is this much. But the designing of 3D, right, requires your skill. So this working with all people and robots are going to make our lives better. Fine, but you can ask, sir, how can I do something? You have been telling about technologies, right? How can I do? That's what we will see. That is where UN has given our sustainable goals. Have you seen this? Has anyone seen this already? No? United Nations, which constitutes various countries, have combined and decided these are the 17 goals, sustainable development goals. So that if you improve all this, if you work on all this, it is going to be helpful for the society. Alright? So you can see no poverty, zero hunger, good health, education quality, like that. Okay? This has been formed by United Nations. And everybody, every country is working towards all this. And when you frame any problem, project, anything, try to involve that one along with that. And that is going to be useful for the society. Alright? We have taken up all these sustainable development goals, and whatever projects I have been doing and giving it to research and other things, instead of just going as a research paper and it's going to be in the library or somewhere, I wanted that to be in the hands of real public. So all such projects whichever I do and design, right, are based on such sustainable development goals. Alright. With this idea in mind, when you see about Society 5.0, whatever we discussed, it contains, for example, smart agriculture, smart food is there, and alert systems are there. You have e-learning systems. We have empowering women with education. So smart grid is there. Your construction is there. Global innovation ecosystem, smart cities, metrology, and remote sensing. Right? All this we were talking. I am connecting it with sustainable goals, and there are people working on it. We have these technologies which we have seen, the disruptive technologies, and we, all these stakeholders, citizen, the public, right, and then the community and the institutions, all these people, startups, subject matter experts, all of them combined together have to work for this. And in that, I have listed out, sir asked me to give out some research problems which you can work on. I have come up with some research problems based on sustainable development goals. Right? If you take up whichever is your passion, take your passionate area in the sustainable development goal, search for some problem, take up and work on it, apply your skill on it, and try to make something useful for the society. Okay? See, low cost water purifier, automated irrigation system with IoT, smart traffic management, right? Apply your mathematics to solve transportation problems, right? Solar powered electric vehicle, predictive maintenance of industry machinery failure, and recycling, autonomous delivery drone, remote health monitoring, early detection and prediction of natural disaster, right? You would have heard of things happening. Smart home automation with voice recognition. See, all these things are being given as Smart India Hackathon problems also in each department. I heard of such hackathons which are happening in India and abroad also. Indian government is giving it to the students who are going to be next pillars of India, right? So you require to try, apply your knowledge to solve such problems. So computer vision, IoT, and autonomous vehicle, virtual reality tool to help patients with phobias overcome their fears in the controlled environment. You can think of machine learning to automatically adjust lighting and temperature based on user preferences. Just imagine a home. You go inside and it detects, okay, Suresh has come. He wants this lighting. He wants this much cool. He wants such a chair. The chair will adjust according to you. The music will play accordingly. The corresponding TV channel will automatically change. Right? All such things. That the heater temperature will change according to what you like, and what is the food you require, that will come. If you imagine like that, right? It's going to customize human based, right? And then biosensors to monitor vital signs and real-time traffic data. Okay? You have these many issues, and specific to computer science research. See, I know you people are also involved with computing, right? And in that case, you can also think of these applications to be developed. Anyway, I know you will not have time to read all this now. I will share it. You can go through it and select few problems. And when you see how, this is what I spoke about in the starting itself. Anyhow, the applications of applied mathematics, if you see, it's with cryptography, medical imaging. As of now, it's applied in medical imaging, computer graphics in 3D modeling and animation. That's what I told. 3D printing cannot happen without mathematics, because you require to create these 3D modeling, and Fusion 360, CAD, all these things are going to be based on mathematics, complete image processing, operation research to optimize your systems, and finance deals with applied mathematics, climate modeling, machine learning, and robotics. All these things is your linear algebra, calculus, probability theory, and control theory, and so on. Alright? So this is what I wanted to talk to you. Hope I made some sense. Right? Yes or no? If it was something useful, just raise your hand and show, so that I can know if it was useful. Good. Thank you. Thank you so much. If one of you choose any of these problems and try to work on it, apply your research knowledge on it, it will be much more useful for the society as citizen of India. Okay. Thank you so much for the opportunity. You can contact me anytime for involving in any such project. I will be happy to help you all. Thank you.
So that vending machine. Vending machine, only one.
Vending machine. If you just go and press, have you tried with only one touch? If you go and yes.
No, vending machine or continue.
No, the question was like there are 3 coolers which are providing different juice, right? So one gives Pepsi, other one gives cola, and other one is giving randomly, right? And I wanted to see one child replaced the stickers, and we have to find out which is what vending machine by pressing it how many times. So by 2 times we can find, that's what people told. With 1 alone we can find, that's what I challenge. How is it? We just go and press your vending machine, and if you press whatever you get, okay. The third one, if you go and press, and if you get, what will be pasted there? It will be pasted as cola, okay? See, whatever you are choosing is, imagine it's a random vending machine. And what will be pasted there? It will be either cola or something else. And when you press that, if you get cola exactly, cola with cola means, actually cola will not be in cola. So that is not going to be, that is going to be a random vending machine, right? And if you get, if it is going to be, what is that, Pepsi. If there is Pepsi and you get Pepsi, then that is not going to be the same thing. If you are going to, If it is going to be opposite, what's going to happen? No, with one alone you can identify. I will tell you just. Okay? Thank you.
Thank you, sir. On behalf of Postgraduate and Research Department of Mathematics, thank you for your spending valuable time in your international conference for Applied Mathematics and Computing 2023. And I would also thank to our Secretary, Sri Ashok Kumar Mundraji, and our Principal, Dr. S. Santosh Babu sir, and Professor R. Venkatramanan, Head, PG and Research Department of Mathematics, Control of Examination, for organizing this conference. Thank you, sir. Now, I would like to invite Professor R. Venkatramanan, Head, Postgraduate and Research Department of Mathematics, Control of Examination, to honor our chief guest with the salt and college memento and philanthropy. Sir, please, sir.
The next section is about to start. I request our HOD to felicitate Dr. Sunil Matthew sir with a flower bouquet and then memento with shawl.
Arijit, AC கம்மி பண்ணு. ஈரஜ் AC கம்மி பண்ணு. ஆள் இல்லையா? உள்ள ஆள் இல்ல. இன்னும் ஒரு செஷன்.
बा ये कर
I request
यूट्यूब में बा
யாருமே பார்க்கல.
ये पीजी है
பிஜி 0
இது லேட்டா கூட பாப்பாங்க
அதுக்கப்புறம்
நம்ம எல்லாமே பீஜி எப்படிலாம் இருக்காங்க
QG சார் ஃபர்ஸ்ட் முன்னாடி பிஜி எனக்கு லாஸ்ட்ல
நானும் ஸ்டூடெண்ட் தான் யூனியன் ஸ்டாஃப் காலேஜ் பிஹெச்டி நம்ம டிபார்ட்மெண்ட் பிரேக்கா
Yes, just a minute. See, let me tell you that solution. Right? So you see, imagine it has the stickers have been replaced and you are sure that Coke, Pepsi and random stickers are replaced. They are not the same. Okay. What I am telling you is you go to the machine with sticker random and press the button. And when you get Coke, okay, actually what is it? So Coke, it is a machine which is not random machine. You know that. It is a particular machine. And if it is giving Coke, it means that it is a Coke machine. Alright? But Coke sticker is in some other place. So you know Coke, that is not Coke machine. You know what is that Pepsi machine. And you obviously know the other one. And if you get Pepsi in that random machine, random sticker, you get Pepsi, then where Pepsi is pasted is not Pepsi machine. Alright? Understood the idea? So if you just write down like this and see, you will understand.
So then the possibility will take place only if I get to the random machine first. What about?
No. Wherever the sticker is random, you go to that and press. He has replaced the stickers and you are sure all the machines are wrongly placed. Stickers are wrong.
So whether placed one time or two times?
Sir, all stickers are randomly ordered. So he has replaced the stickers. So Pepsi machine will contain Coke sticker and so on. Then if I directly go to the random sticker and press it once, if I get Coke, I am sure that is a Coke machine because the sticker is replaced. So I have identified the Coke machine and remaining two is obvious. Okay? So with one you can do. So see, why do we require mathematicians over there? Optimization. With one transaction we will be able to solve this problem. You should not take 2 transactions, 3 transactions and so on. It will cost you more. So if you optimize things, you are going to earn more money in the industry. Okay? Apply all your OR. I am also OR person. Systems engineering and OR was my PG. Alright? So let us make world better. Thank you.
Jai Shri Krishna. Good morning to one and all present here. I, Dr. S. Mainavanan, here to welcome you and introduce today's speaker, Dr. Sunil Matthew, Assistant Professor, Department of Mathematics, NIT Calicut. Sir has secured his Masters from St. Joseph's College, Devagiri, Calicut, and a PhD from National Institute of Technology, Calicut, in the area of fuzzy graph theory. Sir has published more than 75 research papers and written 2 books. Sir is a member of several academic bodies and associations, namely Kerala Mathematical Association, Ramanujan Mathematical Society, Academy of Discrete Mathematics and Application. Sir is editor and reviewer of several international journals. Sir has an experience of 20 years in teaching and research. His current research topic, which includes fuzzy graph theory, biocomputational modeling, graph theory, fractal geometry, and chaos. With this brief introduction, I request Dr. Sunil Matthew sir to deliver his content. Thank you.
Hello, Vanakkam. Good morning, everyone. Anyway, there is lot of energy, enthusiasm, and dynamism in this group. Actually, when I entered this hall, the previous session was in this first stage, you were responding very nicely with a lot of energy and enthusiasm. Thank you. Once, anyway, I'm coming to a college after 14 years. In 2009, I came here to deliver a talk. Okay, anyway, thank you very much for the organizers of this particular event for inviting me to this prestigious institute. Okay, shall we begin? Okay. First of all, I would like to know the anatomy of this audience. So, how many teachers are in this group? Please raise your hands. No teachers. How many PhD scholars? Raise it fully. 1, 2, 3. Only 3. This side? No. How many MSc second year students? Yeah, that's a good number. MSc first year? It's a very less only. And BSc students? BSc final year? Okay, second year? First year? My God. Anyway, it is good. To some sense, it is really good. Generally, I decide my topic only after analyzing the audience. Unfortunately, what happened is, I brought only one presentation today. Okay, it's the only presentation brought for you. That does not matter at all. And what about your computer? Internet is available? Is there? I asked you to do something. I'm typing in Google. Right. Anyway. So why? Anyway, it's a very, very general, old classic question. For what purpose you learn mathematics? So many people ask you about that. Why are you learning all these things, right? In another town, maybe. So I'm asking in a very mild and soft tone. Why are you learning mathematics? It is not like the other town. What is your answer to this? Unfortunately, I cannot do 100% justice to this topic. Anyway, because when I ask the organizers, then probably most of the audience will be PhD scholars, teachers, and MSc students. So don't worry about that particular slide. But that particular slide is also very important. So give me an answer to my question. So only an interactive session, nothing else. Okay, I am not going to show bullets above your heads. Okay? You can ask anything to me related to mathematics. And in the last session, it was a very dynamic session, right? Even sound matters. That dynamism was, traveling in this particular hall. And you have at least seen many applications of mathematics, right? Okay, wait, let us see. So, anyway, I have another problem. I have a very serious problem. Actually, I need a minimum of 30 minutes to reach the topic. So during that time, I will simply wander here and there, the entire universe. I do not think that it will be a problem because of the anatomy of the audience. Fine. So, what is your answer? So, can you just search in Google, just minimize this, James Webb images. Take Google and search James Webb images. What is James Webb? Anybody from the audience? I will send you a gift. James Webb. Correct. Who said it first? But you won't get a gift if you simply say telescope. You will need something else. Fine. Who said it? You are right. It's a telescope only. You are right. Most of us are mathematics people, right? Generally, even in a older in class, I used to tell my student, James Webb, tell him, James Webb, James. Someone please help him. James Webb, okay. Yeah, it's coming there. That's it, James Webb. Yes, that's correct. You are saying something. Just wait. Scroll down. Take anyway, keep it there, first there. Come back to the question. Why you learn mathematics? You are free.
I like to play with numbers, so I learn math.
You like to learn numbers with mathematics. Just 1 second, let me tell you one thing. Okay, then you can do. Raman is also playing with mathematics, right? And I will understand. Heard about black holes? What is that? Black holes. It's only a story. We have not seen any black holes. But before that, generally mathematics students lack two things. One, communication. No, nowadays they are better in communication. They hate physics. Most of them hate physics, not all. There are few who like physics. But personally, it is difficult for me. So most of them hate physics. Second, most of them are reluctant in reading newspapers. General knowledge is combined. Okay, so general knowledge and physics are our problems. So that is why when I asked you James Webb, because in our newspapers it was a big celebration, James Webb images. See, what do you know about the space where you live? What do you know about the space where you live? It is beyond our imagination. Till 100 years back, it was only one solar system. We knew only about one solar system. Okay? And then we started constructing telescopes. We looked into the sky. We saw wonderful objects in the sky. Then we realized that there is something called a Milky Way. Galaxy. What is that Milky Way? Not a problem. Just as Milky Way. Milky Way galaxy. Have you seen Milky Way galaxy? Well?
Recently NASA.
No. She's saying an image. How can you take an image? Is it possible to take the image of this? Okay, take one picture. No, not that one. You take, which one do you take? Pink. So, that one. Yes, that one. That's enough. So how do you take this picture? Huh? It is only an imagination. No one went out of this space. We know how the moon looks like because we have sent vehicles. They traveled around the moon. They took photographs. Right? Yes. But nobody visited this huge, massive structure. Its diameter itself is 100,000 light years. Light years, the distance traveled by light in 1 year time. Suppose you have 100 Janmas, births. Okay? No, 1,000 births. Suppose you live for 100 years. So I suppose you travel in the speed of light. Can you travel in the speed of light? My basic question is, are you traveling now or simply sitting here? What is your speed? Huh? What rotation of Earth speed? What is the rotation of Earth? Mathematics people tell me. No, physics. That is the problem. See, when I asked him about Isaac Newton, he said he is a very famous physicist. Do you think so? He is the most famous mathematician. He only created calculus, binomial series, differential equations, and the biggest research center in mathematics is in his name. He was the location professor of mathematics at Cambridge University. Seems because we don't know much physics, safe side. They say it's a physics. Okay, and Einstein, he said he's a physicist, right? I will come back to Einstein after some time. Anyway, it is really difficult even to visit this place, right? Can you see? You can see this Milky Way with naked arms. One arm, because it is spiral in shape. There are enough reasons to believe so. So that one. So the third image, when the sky is clear, look at the sky. I have seen it with my naked eyes. That third image in the first row, that is visibly the sky. That's an arm of our own home, Milky Way. Actually, which arm we live? Is that about Orion? Orion constellation. So in Malayalam we say Vettakaran, in Tamil it may be Vettakaran, something like that. Vette, what is the meaning of that? One would go for shooting? Tamil. That's right, that's why I told you. That's why I told you. See, that's a constellation. That's a constellation in the sky. And I told you we have a lack of general knowledge. You heard about pyramids of Egypt? Yes. What are they? Actually, they are mathematical wonders. One lifetime is not enough to learn about single pyramid. You just Google pyramids. Actually, there is a story. We believe that body, the dead body of Pharaoh, that king of Egypt, were inside that particular pyramid structure. One day, the minister of Pharaoh had a dream. In that dream, what he saw is fire coming from sky and eating the entire Egypt. He asked his ministers, because they were on the top of mathematics, science, physics and other related things. The Pharaoh asked them to construct a structure so that even if the world is gone, our mathematics will remain intact. That's why they applied all mathematics. They applied all mathematics, like you know, our temple in, after seeing this Ponniyin Selvan, I went to Tanjavur, and that temple is there now. What a mathematical wonder it is. That way, only pyramids were constructed. Actually, the basement itself is in the size of 11 football grounds and height 39 story building height. You cannot imagine. Okay, I am not going to that side now. Come back. See, we are living in a huge universe. When you look at the sky, are you seeing the real sky? No. Because suppose the light from one star takes 3 million light years to reach this earth. And suppose that planet died 3 million years ago. Still you will see the light. So it is not a real sky. If you take a photograph, it won't be a real one. Okay. And another thing, mathematically, what is the model of your eye? If you cut this eye like this, what mathematical shape you will get? Anyone can answer. If you cut like this, someone said correct. No semicircle. It's a parabola. You have seen retards. That's a paraboloid. This is also a paraboloid. You know that parabola has exactly one focus, isn't it? Yes, one focus. That one focus is creating all the problems. That is why we have short sight, long sight, etc. Because when light comes to this paraboloid, it will pass through this focus where there is retina is. Okay, and you know ellipse, you know, right? What 3D of ellipse? Ellipsoid. Ellipsoid, how many focus it has? Two. In New York, there is a building called Murmuring Building. Its name is Murmuring Building. A building where there is no secret. You might have heard about that. See, suppose this room is the shape of an egg, ellipsoid. So one focus that somewhere there, another focus somewhere here. If I speak something, however feeble it is, to my friend, okay, teacher is coming. Just 1 second. Just 1 second. Suppose teacher told me something. Did you hear it? No, sir. Oh, because of this mic. Even otherwise, if I'm standing at the other focus, you can hear it. Because only thing is it should be reflective. So it should go like this and pass through the other focus. That is the principle of removing kidney stone in our hospitals. They will apply a shock at the other focus, it will pass through, okay, something like this, and will go through your stone. Stone will be broken. Anyway, that is an announcement.
Research scholars who have registered for the paper presentation are requested to assemble in AF19 main block, second floor. First floor.
Okay, anyway, you don't worry about the galaxy. The sky is not clear. And the Earth, this solar system is going to die very soon. That's a fact. Not in 1 or 2 years. Maybe in 5 million. Not in 5 million. See, the life of, what is the life of an average star? Physics again I'm asking. Average star life is nearly 13 to 14 billion. 5 billion already gone for sun. In the last, the 1/3 part will be a red giant. So there won't be light coming out of it. Only 5 more billion years if sun exists. But there are so many other alternatives. See, what we have observed is, nowadays, the speed of Earth, the speed is coming down. And what exactly is the speed in which we travel? You didn't answer to me. The total kilometer perimeter is 35,000 kilometers divided by 24. So nearly 1,500 kilometers per hour. That's only a beginning. And Earth, it is going around the sun. In 365 days, it completes its journey. It is traveling 5 times, 10 times faster than that. So 1,500 kilometers per hour. But unfortunately, like an ant sitting on a watermelon, even if the watermelon is moving, and you will never know watermelon is moving and I'm going to die next moment. Yes, but we know that ant is going to die next moment. But I will never know that I'm going to be crushed next moment. So, unfortunately, we are like ants. We are flying in the speed, in a huge speed. That is what is relativity. You can see, the previous speaker discussed about quantum, right? Quantum will be the fundamental thing in the next generation, there is no doubt. For quantum, you need mathematics. Without mathematics, there is no quantum mechanics. Quantum is the quantum physics is the basic principle in the sun is burning. Even sun is working in that principle. Nowadays you have heard about solid state hard disk, SSD, heard about that? Computer hard disk. They are really fast. They are working with the principles of this quantum. But quantum needs probability theory, quantum needs all the mathematical theories. We don't have enough time for that, but that quantum, the word I heard from him, is very, 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 very important for you. Anyway, as an introduction, I asked you about the James Webb telescope. Just go back to the James Webb. See, look at this, that's a telescope. That telescope is situated at 15 lakh kilometers away from Earth. Nobody nobody can go there, nobody can repair it. 15 lakh kilometers. Actually, that is a shape. You can see it made of a hexagon, right? So many hexagons are combined together to make a big mirror. Hexagon is a very important shape. Did you see honeycombs? And why honeybees are constructing their house in the shape of hexagons? Everything is well connected, even if it is triangle, what is wrong with that?
Circles means you can have that intersection.
That is circles.
But
I don't want circles.
in the hexagon you don't have that kind of.
You said one property. Actually, honeybees studied mathematics much before human beings. Okay? You know, when there is a temperature in Chennai, 50 degrees Celsius, you just look at a honeycomb in Chennai itself. The temperature inside honeycomb will be 15 degrees Celsius. You cannot imagine that. When temperature in Jammu and Kashmir is minus 22, look at the honeycomb, it will be 17.5 degrees inside. But we are suffering like anything. We don't have that mathematics. That is what is artificial intelligence. We need that artificial intelligence. Without mathematics, actually there is a movie in Malayalam, name is Padiyam, that was released recently. That says, without mathematics, the world is a big zero. Anyway, engineers and physics people used to mock us with that statement. But that is the truth. Without mathematics, the world is a big zero. And what is mathematics? Mathematics is God. There is no doubt about that. You know what's a black hole? I will come to see. You can see one picture here, right? That's called that's an old photo. There are two. They show this a recently constructed telescope situated outside the atmosphere of Earth. Why outside? If something is inside, what will happen? Totally gravitational pull. There is an environment here, right? Environment is, density of the environment is moving from millimeter to millimeter. I don't know whether you have studied Snell's law, that also is coming in physics. When light attends from one medium to another medium, it deflects. Okay, I will tell the story. See, some 15 years back in all universities in English, mechanics, dynamics and statistics were taught in our mathematics curriculum. Nowadays it is not there because we are playing same side. We don't want to teach anything related to physics. So we should know what is physics. That only. Okay. Anyway, see. Okay. So what will happen exactly? If you just throw a stone in a pond, it will make riddles, right? You look at it, you will not have a clear image. That is happening. When you look at the sky, you are being cheated because the light type is bending. I will ask you a basic question. Along which mathematical curve light is coming from sun to earth? How long will it take? Correct, 8 minutes, correct. Correct, absolutely correct. In which path it will come? Mathematics, there are so many paths. Line segment, circles. Which path? I will send you a gift if you answer this question in 1 week time. You try, guess, make it why you guess. Huh? Wave does not make any meaning. Curve, you might have seen many curves, right? Yeah. Locally sign was that, so many curves are there. You have seen so many curves, I know. Anyway, there is a very famous problem in math. You should read the history of mathematics. That will motivate you. Otherwise, you have to make, I'll tell you another story. And the story is about black hole, I will come ask sometime. Okay, what was the question? Curve. That curve is a very famous curve. Along which curve rabbits jump? There is another animal jumping from point to point. Kangaroo, right? Kangaroo also, when a kangaroo jumps from the point A to point B, knowingly or unknowingly, what will be in his brain? I have to save my energy, isn't it? So simply the entire energy is gone. It is gone. So knowing why a flower is growing like this, what is the purpose of this flower? This is a mathematical, wonder, fractals. That is what is today's discussion, unfortunately. This is a fractal. I don't know, because you need little mathematics. I find mathematics. Frankly speaking, let me come back 1 minute to the subject. I asked you why you need mathematics, why are you learning mathematics? See, you know what is geometry. We started with Euclidean geometry 2000 years back. When Euclid looked out, did he see any triangles there? Huh? Then why did he draw a triangle? Did he see any cylinders there? Any circles? He idealized objects in nature. When he saw the sun, idealized, circle, mountain, cone, tree, idealization. And where did he draw all these things? In a mathematical plane, right? That's called space. Lines, circles, etc. are called objects. Objects live in spaces. But don't they justify anything seen outside? Nothing. So Euclid, but unfortunately, even after 2000 years, you make everything in Euclidean geometry. Look at this: squares, circles, rectangles. But in nature, there are no rectangles. Okay, sorry, just make my presentation. Just take my presentation. I need this movie, I'll come back. Second slide. Yeah, actually, several thousand years back, one mathematician called Galileo Galilei made this statement. Okay, Galileo Galilei made this statement, but it is completely wrong. What he says is, but what he says is the essence of mathematics. As in the movie which I told you, without mathematics the world is a base zero, that is what is here. What Galileo Galilei says is, the world is, it is a book. It is written in the language of philosophy. Circles, triangles, lines, and other geometric objects are the alphabets. That is what he said. Even though he made a mistake in alphabets, what he said is correct. Okay? What he said is correct. Okay, I don't know how long I can talk about that, because we have only 1 hour. So, you go to the next slide. Look at this. This statement was made by a famous mathematician called Mandelbrot in the 50s, I think 1965. Look at this. He said, clouds are not spheres, mountains are not cones, coastlines are not circles, and bar is etc., 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 etc. So, shall I take this leave? Yes, with your permission. You studied mathematics for at least 10 years, right? Can you calculate the length of the periphery of this leaf? Can anybody? I will give you 1 lakh rupees. You calculate the length of this piece of, leaf. 3 centimeters. What is the percentage of objects you see with your naked eyes? Only 5%. I told you, is a very bad mathematical object. Even though construction-wise it is parabolic, it's a very good mathematical idea, only 5% is allowed to human beings. Are you hearing all the noises? Are you hearing? You are not hearing. All these chairs are occupied. Yes? Can you deny that statement? I tell you, there are not people, someone else, sitting on these tables. Can you believe that? You have to. Anyway, one word was necessary here. You know what dimension, right? Dimension. What is your dimension? 3. You say it is 3. If you go to YouTube and search 3D will see a video. It's a wonderful video. Suppose there's a 2D world. Something like when you put a drop of ink on the surface of a paper, ink will spread, right? It's only an idealization, not proper. Suppose there are, living things living in plains. It's only a story. One day, I am visiting that village. I got captured. They put me in their jail. What is their jail? Square, correct. When they close their dimensions, that is their jail. They have lived in pain. So, like that chalk we used to catch cockroaches. When cockroaches cross that line, they die. That way, a square is their jail. Suppose I am inside. I have a dimension which is not known to them. Right? Third dimension is not known to them. Only I can access that dimension. If you have a dimension, you can access that. Since I have 3 dimensions, I can go up and down, I can go left and right, I can take all these 3 routes, right? So, along the third dimension, which is not known to these ants or whatever it is, I can escape. Okay? I will go like this. I will watch them. Right? They will be protecting their jail with AK-47. Imagine the same story with 4 dimensions. Suppose I have 4 dimensions. Okay? You put me in your jail. Okay? Please put me in your jail. I have 4 dimensions. What Einstein said is 4 dimension is time. But we don't know what is the 4th dimension. Einstein said 4th dimension is time. Let us believe him. We don't want time. We can have any dimension. We can escape to that dimension. Right? So if time is the dimension, there are big problems. All these things might be occupied. There may be students who missed my classes in my previous birth, maybe here. Don't worry about it. Here is not the solution. If time is the 4th dimension, and you put me in your jail, what is your jail? Close all the doors. This is your jail. X direction has to be closed, Y has to be closed, Z has to be closed. You can go outside with your AK-47, right? Okay. I have 1 dimension which is not known to you. So if it is time, there is a problem. And about space-time, Einstein's space-time. He says, now take a photograph. Click. X, Y, Z space dimension plus time. I have a picture. Tomorrow at the same time, I take a picture of this room. That's the next frame. Space-time lives in frames. There is a theory in mathematics that's called frame theory. Okay. Anyway. So I live in frames because I have time. I have space-time. I can even bend the space. Don't worry about it. So, along my time axis, I can escape. I will just stand and watch. I will go like this. I can go up like this. Not in physical manner. Okay, so I will be changing from frame to frame. I will go 100 years back along this time axis. So, only forest here. I will have an evening walk. Okay? Again, I will come up to this point of time along the time axis. I will see all of you outside. Right? Time is only an example. If there is a 4th dimension, I can escape through 4th dimension. Because you don't know what is 4th dimension. Right? So, if time is the 4th dimension, and if you believe in reincarnation, and if you believe that reincarnation can take different forms, okay, a human being, a dog, a tree, anything, okay, so things will become more and more dangerous. So let us pray, let us hope there is no 4th dimension. Actually it is there. There is a theory in physics that is purely mathematical called string theory. That string theory says the basic particles which we are made up of are strings. Strings vibrates. That gives us a frequency. They are good friends because their frequency matches. they have almost similar frequency. So even their temperatures may be same because frequency is same. See, you like to talk to some good friends, but you don't like to talk to someone else, right? The energy matters, the frequency matters. Heard about dual personality? I sometimes, one day morning, sometimes I start talking like him. What to do? I can, you synchronize. There is a movie, right? There is a movie. Huh? You know what? I mean, even before that one, another movie is there, no? That was remade from Malayalam to Tamil. Rajinikanth Nayanthara. Chandramukhi. Isn't it? Yes. So that transfer is possible. Suppose, see, Bhasmasura, you know Bhasmasura. Bhasmasura prayed to God, give me that ability, every day by day. After years and years, he got that particular gift. So, suppose, that movie, that character wishes to be the dancer. So, she is passing all the steps. She is trying to speak in the form of, in same way. It is possible. So, when soldiers, move in a bridge, they are not allowed to make this mark past. Why? Because there is a natural frequency, and when the mark past happens, another frequency will be created, and when two frequencies coincide, resonance will occur, bridge will fall down. In Google you can search Tacoma narrow bridge accident. That is what is happening inside your cochlea. That's a very beautiful mathematical model. So MSc students may be knowing about Fourier transforms, right? Fourier series, Fourier transform, etc. This is a Fourier transform device. This diaphragm will cut it into different frequencies. Sa, ri, ga, ma. Sa, ri, ga, ma. There are 4 different frequencies. So when sa moves into the canal, when it reaches to cochlea, there is no board. That's a problem. Whiteboard was necessary. Cochlea is in the space of a spiral. Fibonacci spiral, or logarithmic spiral, or equiangular spiral. That is the shape of galaxies. Okay? That is the space of several things. Even here you can observe some spirals. That's a natural tendency. Anyway, you didn't answer to my question before. Along which line, which curve, light comes to Earth? Sign? No. That is the solution to a famous problem called Brachistochrone problem. Brachistochrone, BRS, differential equation, Simmons textbook. Just read, you can see that story. Brachistochrone problem, that problem is like this. Suppose there is a point A and another point B. Exactly. From A to B, a beam is moving under the action of gravity alone. Along which curve it will reach B first. Okay? Or what is the curve? Actually, even Galileo said it is a straight line in the 45 degree. But that was a mistake. You search, it is called Galileo's mistake. Actually, it is, see, when light went from one medium to another medium, it bends. When it continuously bends, it becomes a cycloid. When it continuously bends, it becomes a cycloid. Cycloid is the curve. Cycloid has plenty of properties. It is called the Helen of geometry. So many properties. Okay, anyway, don't worry about it. So we missed many things. Actually, we must learn physics. Now, as I told you, this James Webb telescope was zoomed into deep space. Okay, at what time should I stop? Any idea? Okay, you have to tell me. Okay, whenever you want, we will stop. See, some 25 years back, there was one telescope called Hubble telescope. It is also outside our environment, and that was focused to a 1 centimeter window, or a window of the size of a rice grain. 2-3 days back, it sent a picture to Earth. And the entire humanity became, stuck by seeing that photograph. It was millions of galaxies seen through a window of 1 by 1 millimeter. So they extrapolated how many galaxies will be there? Billions of trillions of galaxies. You cannot imagine. The world is so. I told you, we have not even gone outside the solar system even today. In 1976, we had 2 space missions. They are called Voyager 1 and Voyager 2. And can you just say Google and search Voyager photograph of Earth. When Voyager crossed Neptune, it took an Earth photograph. It is a wonderful thing. Voyager of Earth. Yeah, that is it. That is it. That's it. You take the just. Wow, which one do you take? Just wait. Go up. First one itself is enough. Or second, or first or second. Yeah, whatever it is. Yeah, that is it. Can you make that one larger? Just zoom it, just Actually, that's it. That's called pale blue dot. Okay? There is a very famous astronomist called Carl. No. Carl? Sagan? Correct. Sagan. Carl Sagan. You have to read the history. You have to search in Google. Carl Sagan. Carl Sagan is one of the greatest ever cosmologists, we can say. Looking at this picture, you say, there it is. All our, is it written there? Problems are there only. In that pale blue dot, we fight each other. You act against each other. You lie each other. You make all nonsenses and nuisances at that pale blue dot. Far away. We are nothing. That's what Carl Sagan said. When Neil Armstrong went to moon and came back to Earth, he said, now I feel very, very, very small. So you must feel that we are very, very, very small. That's the first thing. Anyway, I will come back to Ramanujan after some time, very, very soon. Did Ramanujan visit any of these galaxies? No. Okay, sir, you go back. Go back and take a galaxy. Let's take some of the galaxies. Yeah. How a galaxy is working? It's only a story. There is a black hole inside a galaxy. That black hole gives energy. See, our sun and solar system is being rotated in the Milky Way around the galaxy, around a black hole. What's the name of that? Correct, Sagittarius A. Right? So around a black hole we are rotating. It's a huge distance. We have made only 18 revolutions so far. Only 18 times. You can search it. Anyway, there is a new theory of black holes. Physics people cannot do anything because they have just seen images. Mathematicians, they do calculate. They do calculate how much distance it is. And before that, let me tell you, this James Webb telescope is giving a clear picture about the universe now. How stars are forming. If there is time, I will tell you about that. Very beautiful story. How a star is forming, what will happen after it's dead. Many interesting things are there. See, James Webb telescope is now situated at 15 lakh kilometers. Sir, please, James Lagrange point. James Webb Lagrange point. Actually, one of our peer team member, okay, Lagrange, that's a mathematician, right? 300 years back, That's it. That last any picture, that's an assumption. That is it. A mathematician called Lagrange solved a problem called three-body problem. So three-body means sun, earth and moon. So suppose we keep an object in the space. If it is near to sun, it will fall to sun because of its gravity. If it is near to earth, that also will die. So can we find a point in the space surround near to this where none of these bodies put any sort of effect? It was solved by him, a mathematician. We must be proud of. He said there are 5 points. Look at that. L1, L2, L3. You can see sun, earth, and moon. There are 5 points. They are called Lagrange points. If you have a vehicle at that point, there is no need for any energy. It will move in a free flow. Actually, our system revolves. So it will be there, intact, forever. No force will be acted on those bodies. Otherwise, we cannot place a telescope there. It cannot leave because we cannot go there. That distance is 15 lakh kilometers. See, Hubble telescope, all are mathematics only, but we need time to tell you what mathematics is used there. I missed one mathematics. I asked you about hexagons before, right? Yeah, I have to answer it first. Then only I will go to space. Space is very, very long. And sometimes I simply look at the sky and wonder what a space it is. You do have the same. Then mathematics will come to you. I told you there is a black hole at the center of every galaxy. You know who solved the black holes? It was Ramanujan who solved a black hole. In solving the mathematics of black holes, you may just search it, actually not now, after some time. Ramanujan's theorems helped in finding the several properties related to black holes. There is a black hole equation, actually it is solved by Ramanujan. No, from Ramanujan's notebook, we got sufficient material to solve this. From where we got the information? That's why I told you, mathematics is God. Mathematics will come to you. You just earn for mathematics, mathematics will come to you. Yes? Okay. I come back to the James Webb. And James, so I told you, James Webb is giving plenty of information about this universe. There are stunning, you take the second photograph, sir. Second photograph, second one. NASA, second one. This is a photo taken by James Webb. Can you say what is it? Actually, every day I am looking at this. Is there? Can we see a nebula with naked eyes? Yes, it is. I told you about Orion constellation. Oh, I didn't tell you about the connection with the Orion galaxy and the Egyptian church is there. Anyway, in the Orion galaxy, it has a belt and a sword. In the sword, you can see 3 stars. Anyway, let it be there, you take Orion galaxy. We are in the Orion arm of this, our galaxy, Milky Way. Why it is called Orion is, the Orion nebula is there. Yeah, Orion galaxy. Look at, wait, just wait. That one. The first picture you are seeing is a nebula. We are seeing it as a star, but it is a nebula. In a clear sky, you can see colors. It is. So, it will take some time. Actually, it's available there. You may just go through Google. We are in the Orion arm of the Milky Way. Why it is called Orion arm is there is the Orion nebula. What is the nebula? Actually, you are wearing a gold chain, right? From where you got this gold? A simple question, not necessarily mathematical. From where you got this gold? Asteroid. Not from asteroid, not necessarily. Do you think the asteroid brought it to our house? No. silver, gold, iron. Do they make any of those things here in earth? Then from where it is coming? Actually, this Carl Sagan said, we are nothing but star dust. We are nothing but star dust. What are we made up of? Star dust only. Because what is basically H2O? A good amount is water only, hydrogen and oxygen. What is happening inside a sun? A star? Sun is a star. See, this quantum is coming there. Lot of mathematics is coming there. Okay, I am not going to talk about these applications, we are enjoying nowadays. Unfortunately, they are simple applications only. We need more applications. We need more. And we don't know how much time I will get. So, inside sun, how actually a star is simply a hydrogen ball. Only hydrogens. Only hydrogens. So what happens is, if there is more and more and more hydrogen coming together, with the temperature and pressure, hydrogen will be converted to helium. Next element in the periodic table. Okay? Helium is a heavier element. So this heavier element will go to the core of that. Actually, our story begins before. We have to discuss it in the perspective of a nebula. Nebula is a cloud of gas. All elements are there. It may be the might have formed by the explosion of the star sometimes. Debris of a star. When a star, what is the name of that particular phenomena? Star explosion. John? No. Big Bang is actually, I never believe Big Bang theory. What Big Bang theory says is the entire universe started with a single seed, one point with infinite density. There is a point with infinite density. Division by zero is allowed in one point in this universe. Can somebody say? Center of? Correct. What's your name? You come and meet me, you will get a gift. Okay. At the center of a black hole, how many minutes? 10 minutes, that's enough. Anyway, nothing happened today, right? We didn't go to practice. Let us go to space anyway. Okay. At the center of the galaxy, there is a division by zero emitting time. When we say that an object is a black hole, when light cannot escape from that, can you escape from this earth to the deep space? If you jump, will you go out of this close? But if you jump with a force, you might have been seeing Marvel movies, right? So in that Black Panther movie, one man with some wings is going up. If you have a wing, you can also go like that. Okay, if you can fly, and if you fly with a particular velocity, you will go out of this. That's called escape velocity, right? Yes, there's an escape velocity. So, if the escape velocity is equal to the velocity of the light, what will happen? You have to jump in the speed of light. If the escape velocity is more than that, what will happen? Even light cannot go. What is the speed of light? Nearly. Can you travel in the speed of light? I told you, our galaxy, our own home is 100,000 light years across. So, if you travel in the speed of light, or otherwise you find a mathematical formula to bend the space. Have you seen the movie by that Nolan? There was Interstellar. In Interstellar, he made a precise mathematical formula. Exactly. Okay. So in that way, otherwise you will never visit your own home, right? So if your speed increases, what happens? Again, physics is coming. Exactly. So you draw two circles. You come here, myself will stand here. Both of them will have a stopwatch. He is running. I am standing. He is running in the speed of 100 meters per second. You are very slow, you won't get a gold medal in Olympics. Right? So, but At 10 o'clock we start this process. At 10:10 in my clock, his clock may be 10:09 something something something, but may not be visible to our very bad eyes. Your eyes cannot recognize. Oh yes, I missed this. I am coming back to this. Okay, so if I am like we give key to this toys. I am increasing his speed. So what will happen is his time will dilate. It is called time dilation. When he reaches the speed of light, his time stands still. So he is at 10 o'clock all the time. His clock will never show anything other than 10 o'clock. Okay? So we cannot travel in the speed of light, right? Okay, we missed at some point, only 5 more minutes left. So let us quickly, in 5 minutes, see the presentation. Sir, please take that video. Only 5 minutes. I am not going to bore you, but make it full. Why you learn mathematics is to just measure the length of this leaf. That is the question. Just to measure the length of this leaf, I am learning all the mathematics. Can you measure the length with this mathematics? No, I cannot do that. The mathematics I have, what we have, or everyone have obtained, generated, introduced is absolutely insufficient to measure the length of this leaf. Okay? Okay. Go. Look at this. See, you can see so many things there. Fractal geometry is the geometry of the nature. Any of the classical geometry like Euclidean geometry, then geometry on the sphere. What is the name of that? Is the geometry on a sphere and geometry on a plane are the same? You draw a triangle on both. You can see a spherical triangle has angles some more than 180. So they are different. All classical, all things, you throw it away. This fractal geometry, you can deal with nature very nicely, but it is very difficult. All the mathematics you have studied and to be invented for the next generations, in next generations are required. It's insufficient. Okay? See, they have, every object in this nature is a fractal. They have some properties. Look at, go down, speed. Actually, this is the man who introduced fractal geometry, father of fractal geometry, Mandelbrot. Go, sir. You might have, at least some among you might have studied this curve. The nowhere differentiable curve of Weierstrass. Equation also is written there. So when you studied, did you think about this curve? What's the application of this? Actually, no curve or every curve in this universe is nowhere differentiable. Are you getting it? If I draw a curve along the surface of my skin, don't believe that it is a smooth parabola. It is like same thing. The boundary of this leaf, with naked eyes you can see many things. But if you zoom it, you will see many crook and bends. It is like measuring the coastline of England. With a 1 meter scale, you can measure it, and as she said, it is 20,000 kilometers. But with a 1 centimeter scale, if I measure it, I can measure more crook and bends. I can say 25,000 kilometers. But he is coming with a 1 nanometer scale. So he will get 35,000 kilometers. He is coming with a quantum scale, 1 lakh kilometers. So what exactly is the length? That sequence is diverging. 25,000, 30,000, 32,000, 1 lakh. Where that sequence is going? What is infinity? Infinity means I don't know, sir. That's a mathematical technique to say I don't know, sir. Okay? Because it is not stored in my memory, sir. Finally, there is nothing called infinity. Okay? So if you don't know what exactly is 1 million, 1 million is infinity. Okay? My infinity is only 1,000. I cannot visualize more than 1,000. Even this group, I don't know how many is my infinity. Sir, please. You know this standard set? It's a wonderful thing. Actually, you know where it happened? It happened in the beginning when an electrical engineer studied the noise transmitting through a cable. It was not invented by a mathematician. Then Cantor introduced a mathematical method. Actually, how we read the second and third stages. You take a 1 meter scale, cut into 3 pieces, remove the middle. Repeat the process. Mathematically, we are applying functions. On the first 1 meter scale, just put the function f of x equal to 1 by 3x. So you will get 1 by 3 of that. Also, f1 of x equal to 1 by 3x plus 1 by 3, something like that, 2 by 3, right? Whatever it is. Okay, go, quickly. These are all famous fractals. Okay, very famous mathematician studied about this. Go. I am simply skipping this. Just look at this side, not BSc. BSc people can close their eyes. MSc people look at this. BSc is alright, then look at this. It is the definition of Hausdorff-Besicovitch dimension. Better theory is difficult for you, right? Okay, so I am not asking you to learn what it is. Generally, a fractal is defined as an object whose, actually it was intended for research college and MSc students. Sorry for that. And if it was known to me, I would have come with a lot of universe pictures, black holes, worms, this, that, very wonderful things. Next time I will come with that. So, okay, this is a very, when I went to IIT Hyderabad for an interview, they asked me this question. I was totally helpless. Even today I am totally helpless. Okay, go next slide. Next. Wait. What is topological dimension of an object? MSc students answer to me. You cover an object with the words. You know cover, right? Yeah. What is the minimum number of overlapping possible? If it is a line, one ball. Like you take your bangles and arrange like this, maximum interaction is 2. Not maximum, minimum interaction. Maximum you can have any number. So, just next slide. Next, yeah. Look at this. This is a cover, right? Yeah, next slide. This is it. You remove those things. The interaction minimum intersection is 2. That 2 minus 1 is the topological dimension. Any object whose Hausdorff dimension is greater than topological dimension is called a fractal. At least we came up to the definition. Now you can go at the speed of light. Yes, wait, not light. Not light. 2 minutes, finish. Okay, next, I will say next. See, this is a fractal. One of the property of fractal is self-similarity. Look at this. Several parts are similar only. This eye and this eye are similar only. Here, different portions are similar only, right? Yes, so they are fractals. Right. And next, look at this. All these things possess similarity. That's why they are fractals. Okay, next. Cauliflower, go. We don't want this now. Okay, next. Tree is a self-similar fractal. See, just an example. At least that way sometimes it will hit you. When you take a photograph of this, that is another big story. You can take a photograph in my phone and in your phone. If my phone is iPhone, which will be more clear? iPhone. Why? The data analysis is coming there. My data is small. My picture is 3 MB size, where your picture is 1 MB size. Are you getting that? Yes. So, when you communicate it, when I send it from one point to another point, which one will be easier? In my place, I have to climb up on my coconut tree for data and for downloading data. So, I will be unable to download Apple data, but I will get your image. Right? So, communication is a big mathematical problem. Right? So, why you send everything? Instead of sending my entire face, all my hair is, everywhere is there, right? Right? So, it's enough to send a sample of that. Right? And just a mimic, you will definitely get my picture. And most probably left eye and right eye, similarly. Several parts similar portions. So that's a new way of communication. That's called fractal transforms. Fractal transforms. That is the new fractal transform. Anyway, just remember this word. So this tree is not needed for us. Go. Quickly, only 1 more minute. Our length, just 1 minute. Our length is a fractal. What is the volume of our length? Finite only. Volume. But what surface area of that? Infinite. Because it has to absorb the maximum air. So actually, it has infinite surface area, but finite volume. That's the property of fractal. Last minute. Go quickly. I will show you some beautiful fractals. Go. No, not here. Not needed. That's all for your future work. Wait. Okay, go. Just go to previous slide, sir. Just wait. Did you see this before? Have you seen this before? When I was a child, I used to take one of this and do like this. So the instruction will be over by hand. Okay, that's called a fern. But this is not natural fern. This is a fern made by me in my computer. Is it real? Yes, it is real. Your classical geometry cannot make this real, but fractal geometry can make it real. Fractal geometry can create anything in this universe. I will show you how a tree is generated. Go sir, go quickly. They were all beautiful things. We'll discuss it next time. Wait. Start from very beginning. Just go. No. I need that tree. Go back. Where is our tree? No, I think forward. And I cannot go like this. We have plenty of other activities here, no? Wait, go. You keep this branch always fixed. Okay? Now, dilating. Have you studied about contractions? For example, 1 by 3x is a contraction. The length will be reduced by 1 by 3. Plus something means it is translated. Ax plus b where more or less than 1 is a contraction plus a translation. Okay? Similarly, you can add a rotation and contraction. So, take such a function. Next slide, sir. Look at this. I have two functions, contracted and translated. So, go continue. One slowly. Yes. But every time you keep this, that one log as fixed. That's called condensation step. Proceed, sir. See, I am making a tree. Go. So in fractal geometry, things are more realistic. That's what I'm trying to tell you. See, that's a real tree. With classical geometry, you cannot do this. Proceed. We don't want this. I will tell you where to stop. 30 seconds more. It is like a cricket match. That's the previous one. Previous. I will stop with telling you just previous. No. Proceed further. Yeah, stop there. Last minutes. This is a very famous object called Mandelbrot set. The largest or the mega mathematical invention of 20th century is not this one. It is Albert Einstein's E equal to mc square. I need little time to tell you about that. Unfortunately, it is not there. The second mega event is this. It is believed that this is the second biggest mathematical invention. Okay, but we need more time to investigate. Actually, the boundary of this. Okay. Finally, I am showing the boundary of this after this one. Every pattern in this universe, even those which you see in your dreams, are on the boundary. In your dreams, you see some colors, right? It is there. So we'll stop with that. Let's go further. Yeah, look at this. There is a related thing called Julia set. It is very simple. They will not give me time. That's why I am not going to say anything more. F of set equal to x star plus d. That's a function. Complex function, right? Iterate the complex function. Okay? Set of constant c so that orbits of 0 are bounded. That is what is Mandelbrot set. And for a particular constant c, set of all complex numbers which have a bounded orbit. That is a Julia set. You can do your MSc research project in this area. This part is called complex dynamics. Right, look at the pictures. Picture, go. Yeah, see, look at these pictures. Wonderful standing pictures you will never see it anywhere else, only in mathematics. So they are, see, the function, everything is given there. Go. Yes, look at this. Go. Say thank you. Okay, just one more second. Finally, I told you, even the images in your dreams can be seen, right? There is a video in that folder, sir. Please find it. Wait. Look at the boundary and see the patterns appearing on the boundary of matter board cell. With hi-fi computers, you can generate the neuron room. As you go further, you will see complex, beautiful, unimaginary patterns. Sound is not required, sir, just picture. We will discuss more about this in the next class. See all the patterns, all your dreams, everything in there. Sir, session is over, you can finish. Just take YouTube and see the boundary of Mandelbrot cell. Just search. You will become, amazed. There is no doubt. Otherwise, just write an email to me that I am not amazed. Okay. So, thank you. See you again. I told you in the beginning now. Now only, actually we reached our percentage. Today it took 1 hour exactly. That's my weakness. Well, not exactly circular because from sun to the atmosphere, if it is locked up, it will be straight direct line. But not locked up. That will be. I will want to do it.
Any questions from the participants?
Anyway, you can ask your doubts. Okay, in my email. My email is SM, Sunil Matthew, SM, @ National Institute of Technology, Calicut, NITC.academic.india. SM@nitc.ac.in. Okay, short form of Sunil Matthew @ National Institute of Technology, Calicut.academic.india. Okay, SM@nitc.ac.in. You are always welcome, right? But you must know mathematics. What is mathematics? Because without mathematics, the world is a big zero. Exactly. Because we must talk for mathematics. If we don't know mathematics, as we are afraid, it should not happen. Yes. All the best to you.
On the behalf of Management, PG and Research Department of Mathematics, Dwaraka, Goverdhan, Vaishnav College, I would like to extend my sincere thanks to Dr. Sunil Matthew sir for this insightful and engaging presentation at our conference from fractal geometry to space and space to fractal geometry. Thank you, sir.
Yes, thank you.
So, the valedictory function will start at 12:30 sharply. We can have a break for 5 minutes. Yeah, so within stipulated time we should be here. So 12:30 it will be start. Then if you don't want to go after the valedictory function, you can go. Okay. Lunch will be arranged in SRG auditorium. You can have. Okay.
After the validation.
After valedictory. 12:30 is valedictory. Only 5 minutes more. So no need to go. Please be seated. Please be seated. Only 5 minutes more. Principal is on his way. Principal is on his way. Please don't go. Be seated, please.
For MSc students, get a fellowship, CSIR or what MPH partner dish, and if you are interested in doing research in fractal geometry, just write an email to me. I will consider you. Right? Okay. With the fellowship, I can guarantee. Without fellowship also, you can apply for PhD and NITs all over India. Especially if you have interest in fractal geometry, you can approach me. Right?
நெட் இருந்தாதான் வரும் நெட் இருந்தாதான் ஸ்காலர்ஷிப்
அதெல்லாம் இல்லை என்கேஜ்ல மெட்ரியும் ஃபெலோஷிப் ஸ்காலர்ஷிப் வரும் என்ஐடிஸ்க்கு எல்லாம் போனால் அங்கே ஸ்காலர்ஷிப் தனியாக உண்டு பக்கத்தில் ஒன்று உட்காந்துருக்குல்ல அது மேக்ஸ் லெக்சர் கிடைக்கும் இல்லை பிக்சர் காட்டுதான்
Students, come fast.
அவங்க செகண்ட் இயர்
Guys, lunch token will be issued after the validity function. Okay, so with that only you will be allowed in the SRG auditorium. Okay. Get the lunch token and move out. Okay, after the validity function was over.
யாருக்குமே தெரியாது
Just 80. Just yesterday just 88 with my age. 88 divided by 3 my age.
Guys, there will be attendance sheet with your class teacher. You have to sign it. Okay? After validity function.
White sheet வேணும் என்டர் பண்ணி நேம் என்டர் பண்ணி நோட் இருந்தாலும் ஓகே அப்படியே நோட்டா கொடுத்து நோட் நீ ஃபர்ஸ்ட் இயர் பண்ணி கொடுத்துறீங்களா
ஆனா மொத்த கிளாஸுமே நம்ம கொடுக்கலாம் இங்கேயே வச்சு
இல்லை இது அட்டெண்டன்ஸ் யாரும் இருக்காங்கன்றது ஃபர்ஸ்ட் இயர்ஸ் ஒரு பக்கமும் செகண்ட் இயர்ஸ் ஒரு பக்கமும் வந்துட்டு அவங்க வந்து பிரிண்ட் அவுட் எடுத்துட்டாங்க அட்டெண்டன்ஸ்க்கு நாங்கள் பிரிண்ட் அவுட் எடுக்கல அந்த பொண்ணுக்கிட்ட ஒரு 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 கேர்ள்ஸ் கிட்ட நோட் வாங்கினேன் நோட் வாங்கிட்டு அவனை என்டர் பண்ணிட்டு கவுண்ட் வாங்கிட்டு ஃபர்ஸ்ட் இயர் ஒருத்தர் செகண்ட் இயர் ஒருத்தர் இவங்களுக்கு
இவங்க யாருமே வரல
பசங்க யாருமே வரல சரி அப்படி வந்தாங்கன்னா அது நீங்க பாத்துக்க
அது நீங்க பாத்துக்க டோக்கன் கொடுத்துங்க
டோக்கன் இருந்தா தான் எஸ்ஆர்ஜி
இல்ல பெரிய நான் சொல்லுங்க நீங்க பெரிய டோக்கன் இருந்தா தான் எஸ்ஆர்ஜி யூனிக் மொத்தமே தெரியும்
ரோட்டோகால் படி டிமாண்ட்ல என்ன நடந்ததோ
மொத்தமே தெரியும் எதுவுமே
வெளியே சொல்ல மாட்டேன்
இதேதான் சொன்னீங்க மொத்தமே தெரியும் வாய்ப்பு தண்ணி ஊத்த மாட்டேன் வெளியே மூட்ட மாட்டேன் லாரி மண்ணை எங்க மேடம் நீங்க தானே சொல்லுங்க எல்லாம் ஹெச்ஓடியோட யாருமே முடியல சார் வித்யாவதி எனக்கு சொல்ல வித்யாவதி நோட்ல வித்யாவதி
ஏங்க அங்கே உட்கார வச்சுங்க அப்படியே நம்பர் நோட் பண்ணிடுங்க ரோல் நம்பர் எழுதி தூக்கி போட்டுனே இருக்கும் அவ்வளோ முடிஞ்சிச்சு சைன்லாம் வாங்காதீங்க ரோல் நம்பர் நோட் பண்ணி சொல்லினே ரோல் நம்பர் சொல்ல டோக்கன் வாங்கிக்க போ முடிஞ்சு போச்சு
அங்கே யாரோ ஒரு 3 பேர் வரானுங்க பாருங்க அவங்க யாரு கேளுங்க ராஜசேகர் சார் ஒரு 3 பேர் வந்தானுங்க யாருன்னு கேட்குறேன்
எந்த 3 பேர் அது ஈவினிங் காலேஜ் பார்த்துட்டீங்க ஐடி கார்டு பார்த்தாச்சா ஐடி கார்டு பார்த்துட்டீங்களா
போட சொல்லுதான் போடாமல் வந்தாங்க போட சொன்னாங்க தான் எங்கள் பெரியவர் அங்கே கூப்பிடுவோம் பெரியவர்
Guys, call your friends and ask them to come immediately. Principal sir is on his way.
முடிஞ்சுட்டு தான் இங்கே வராங்க முடிஞ்சுட்டு
அங்கே நான் போயிது பிரசன்டேஷன் பேப்பர் பிரசன்டேஷன்.
Try to accommodate front row, please. Those are sat at the back, please come front. Occupy the front rows. The last row. The last row, heroines, come front. Occupy the front row. So there will be more seats, come front. The last row. Just come and occupy the front seats, please. இங்க வாங்க ஃப்ரண்ட்ல உட்காருவீங்க.
சார் லைவ்ல நம்ம தான் போயிட்டு இருக்கோம். ஷர்ட் தான் தெரியுது சார். சார் இந்த ஸ்லைடை மாத்திரம் நல்லா இருக்கும்.
என் குழந்தைங்கலாம் வந்துட்டாங்க.
இல்லை சார் இன்னும் 10 நிமிஷம் இப்படி இருக்கு. குழந்தைங்க வந்துட்டாங்களா யாரு? பரவாயில்லையா? ஒன்றும் இல்லை இங்கே க்ளோஸ் பண்ணிடுறோம்.
கேமரா ஆஃப் பண்ணுங்க.
கேமரா வேணா ஃப்ரண்ட்டை ஃபோக்கஸ் பண்ணால் நல்லா இருக்காது. இல்லை சார் இல்லை ஆஃப் பண்ண பிளாங்காக தெரியும். இல்லை சார் ஸ்லைடு போட்டால் நல்லா இருக்கும் இல்லையா? அது அவதான் வரணும். நம்ம எதாவது மாற்றி கொடுத்துட்டோம். இருக்கு சார் வேண்டாம் இருக்கு சார். சார்ஜ் சீவ் இல்லை சார் வரமாட்டாரு சொல்லிட்டாரு. சார்ஜ் ஓகே சார்.
எப்படி சொல்லிட்டாரு? குழந்தைங்க ஐடி கார்டு போடணும். வெளில தெரியணும் வச்சு அவனே தெரியாது குழந்தைங்க. முதல்ல இவர் ஐடி கார்டு போடணுங்க. ஒரு வாத்தியார் அந்த நீங்க
போட்டுருவோம் சார். அப்போ லைவ்ல போய்ங்களா? சாலும் போட முடியாது. அவர் சீவ் இல்லை
சார் கொஞ்சம்
Max with CA peoples, Max with CA Uni College. You can collect your lunch token from Rajkumar sir. Rajkumar sir. BSc Mathematics, MSc Mathematics, Shift 1, you can collect your lunch token from your class teacher after signing in the attendance. After valedictory function, you can sign in your attendance and then you can collect your lunch token from your class teacher. last row. The last row papers come here. The last row come and occupy the front seats.
கண் மாதிரி வச்சுக்கிறாங்க பாருங்க.
இல்லை இப்போ இதையும் பார்க்க நல்லா தான் இருக்கு. ஆக்சுவலாக ஃபர்ஸ்ட் ஆல் யாரையும் உட்கார வைக்க வேணாம் அதை எல்லாம் ஸ்டேஜ் போயிடுவாங்க சார். அது ஒரு ரூம் மட்டும் யாரும் இல்லை அதுதான் இல்லை எல்லாம் ஸ்டேஜ் போயிடுவாங்க. இதில் மட்டும் என்ன பண்ணுறது ஜூம் பண்ணிக்கிட்டா ஸ்டேஜில் எங்கே ஜூம் பண்ணாங்க அங்கே பேசுறது மைக்கு பேசுறது இப்போதைக்கு வீட்டில் இப்போ இந்த ஸ்கிரீன் தான் இப்போ பேனர் தான் வச்சிருக்கியா? பேனர் ஓகே பார்த்து
போய் முடிஞ்ச உடனே திருப்பி மேலே நைட்
ஜான் சொல்லிட்டு போயிடலாம். நம்மளோட தான் அங்கே இருக்க லேப்டாப் எல்லாம் கொண்டு வந்தாங்க. சார் நீங்கள் உங்களோட பேக் எடுத்துங்க, எங்களோட இவன் எடுத்து வந்து
காரை நான் என்ன போட்டு எடுக்கிறேன். இல்லை இல்லை பேன் தான் ரெண்டு மூணு சொல்லி கொடுத்துட்டு போகலாம். ரெண்டு பண்ணிக்கிட்டு நம்ம எடிட் பண்ணிக்கலாம். நமக்கு எப்படி வேணுமோ இதுக்கு போயிட்டு இருக்கு ஸ்டீம் ஆகிட்டு இருக்கோம். நம்ம எடிட் பண்ணிடுவோம். எடிட் பண்ணிவிட்டு ஆப் ஆகிடும். நம்ம பேர் கொடுத்துக்கலாம். இன்னும் எடிட் பண்ணும்போது வீடியோ வந்து செகண்ட் 7 செகண்ட்ஸ் டேட்டா 100 minutes நம்ம 7 செகண்ட் லேட்டாக நடக்கிறதுக்கு அவங்க 7 செகண்ட் ஆனால் கொஞ்சம் டைம் எடுக்கும்டா கொஞ்சம் டைம் எடுக்கும் இல்லை கிளியராக 180 3000 சொல்லிட்டு போனா எனக்கு புரியல அவங்க தெரியாதா நாம இங்க எடிட் பண்ணிக்கலாம் அங்க அது ஃப்ரீமேட் நம்ம பேர் கொடுத்தாதான் இங்க பண்ணலாம் இப்போ நான் பேர் இல்லை தெரியாதா ஏன்னா நீ கடைசி என்ன போட்டு அது ஓடிக்கிட்டு இருக்கோம் எடிட்டிங் நடந்துகிட்டே தான் இருக்கு வேணா பண்ணிக்கலாம்
Yes, I request Dr. Pradeep G. Siddheshwar sir, Dr. K. A. Venkatesh, Dr. Lakshmi, Dr. Vidyotama, Dr. Sunil Matthew, and Dr. Robinson, Dr. Nagapen, and Dr. Sharavanan onto the dais. Professor Devika and Dr. Hariharan sir. Yes, namaste to everyone for the valedictory session of a two-day international conference on applied mathematics and computing. Let's welcome all. To improve the golden moment of opportunity and catch the hook that is in our reach, it is of great art of life. A very good afternoon to one and all. I take it a great privilege in welcoming our principal, Dr. S. Santosh Babu, Chief Guest, Dr. K. A. Venkatesh, and all the resource persons for this valedictory function, ICAMC 2023. I request our principal, Dr. Santosh Babu, to hold the presidential address.
Good afternoon to all. The 2 days international conference went very well in our institution, and I am very happy to note that the resource persons from various institutions, from IIT, Christ University, and other places have attended the conference. And also today's chief guest valedictory function, Dr. K. A. Venkatesh, Dean and Professor, School of Mathematics and Natural Science, Chanakya University, is with us from all the 2 days seeing the proceedings. And we had a good deliberation at the board room yesterday, where the professors, learned professors from various institutions have given a lot of input for our institutions, especially for student development and faculty development. Yesterday around 11:30, we had a discussion at boardroom, and a series of discussion I went during the time how to improve the research. Not only improving the research, we had a discussion about how to improve the quality of teaching for the students also, where the faculties of mathematics department have attended that discussion, and we get lot of inputs from them. I like to thank them for providing the inputs for us for the development. And for the past days, and also for the past 2 days, you are witnessing the online presentation and also offline presentation of various scholars, which would have helped you to go for further research, or you would have learned something new topic from them. Really, these 2 days is a very important day for our students. Like what I said in the inaugural function, usually the conference will take place only for the research scholars and the faculty. But here in Goverdhan Vaishnav College, we are doing it for the students. So the students who are sitting in front of this auditorium would have gained a lot of knowledge, who are the future faculty members, who are the future scientists, who are the future of the country. I hope that you would have enjoyed the conference and you would have got knowledge on robotics, knowledge on artificial intelligence, and also a core subjects like mathematical subjects, you would have got knowledge. Definitely, after the conference, you can refer the relevant content through textbooks and through internet, and you can develop your skill on your own. With these few words, I like to congratulate the head of the department and organizing secretaries of this particular international conference on applied mathematics and computing for meticulously planning. I know very well that they are working for this conference for the past 15 days, fixing the resource persons, fixing the experts, reviewing the papers, preparing the proceedings, newsletters. For this, the whole department, PG and Research Department of Mathematics, are working together as a one family, and because of that only these 2 days conference have happened. Once again, I like to congratulate the head of the department and other faculty members of, not only the faculty and also the students of mathematics for participating. Thank you very much.
Thank you, sir. Thank you for your enthusiastic words. The fragrance of the flowers spread only in the direction of the wind, but the goodness of a person spreads in all directions. We are delighted to have Dr. K. Venkatesh as an honorable chief guest for this valedictory ceremony. I now invite Dr. K. Venkatesh, Dean and Professor, Chanakya University, to give the valedictory address.
Good afternoon to all. So this deliberation 2 days, some way you might have got some benefit. So one is, if you look at that, the speakers from northeast to almost all the parts, except some east part is Venkataraman did not cover. Otherwise, it could be a national integration program. Very interesting thing happened. The deliberations, how many of you understood and taking it? So one sincere suggestion to you is, as a student, when you are not doing the routine, what is the takeaway at the end of this program? If you say a couple of points, the purpose of having such conference or seminar or workshop makes meaningful. Otherwise, as academic fraternity, we'll add in our resume, as well as attendee, they will add in the resume. But end of the day, it is useful to the learning community or not. In that direction, this college, last 2.5 years, I'm associated with some way. They are doing a lot of good things for the learning community. So, as yesterday in the deliberation, we also had a discussion with other faculty members, the principals. In addition to that, I want to add one point, and here Professor will also say the same thing. We'll have a particular calendar. This is the month our conference. It may be international or national or a particular theme. It has to attract the research scholars throughout the country. So they have to expect, yes, there is a DG Vaishnav college, there is a conference, this is a calendar. So if they are able to do that part, we'll have more meaningful and other things also. Benefit is much higher. So that is supposed to be requesting Venkatramanan as well as principals to look into it. I sincerely thank all the speakers without hesitation. They came over here. All of us, we know that has happened just 2 weeks time. The 2 weeks is for implementation. Earlier to that, Venkatraman sir started interacting with many people much ahead of time. So that's how it has happened. Or getting any one of us may be tough within short span of time. Some of us will come because of we need for various purposes some kind of exchange ideas and other things will be coming. So if you look at that, the speakers as well as the international level people have come. Unfortunately, Dr. Lakshmi is happened to be in Bangalore. She also agreed to come over here. We made it precisely is an international conference. The same way, if you have enough time, definitely would have attracted some international participants from the other countries also. That is possible. Otherwise, calling just for name, I'm not happy with that way, international conference. So whenever I say this is not, at least 25% papers from that side and this. Here also we have done a good job. If you're able to do little more better planning and other things would be nice. There are some sessions I wanted to attend, I could not attend because of the one as paper presentation, other side, a lot of speakers also we had. Next time we'll plan it nicely so that it will be useful to us also. So I have nothing to say beyond that. Thank you so much.
Thank you, sir, for your influential message and suggestions. Now moving on to the certificate distribution. I now invite the delegates who presented the paper in the offline mode to receive the certificates. Mrs. Shiny Pauline from Lila College. Mrs. Jiva Sherlin from Lila College. Mrs. Jayashree from Jebas College. Ms. R. Gayatri from Jebas College. Ms. Kirtana from Ethraj College. Ms. Mala from St. Thomas College of Arts and Science. Ms. Gomati from Sairam Engineering College. Mr. Somasundar Ori from DDGT Vaishnav College. Ms. Saranya from Sri Krishna College of Arts and Science. Ms. Monikita from Sri Muthukumaran Arts and Science College. PG students have done the paper presentation, and Dr. R. Sivaraman, Associate Professor, PG and Research Department of Mathematics, has charged the section. Now follow the person. Balaji, Mr. Balaji from first MSc. Satish Kumar from second MSc. Sandhya from first MSc. Shakti from first MSc. Vignesh Kumar from first MSc. Vidya Priya from first MSc. Yamini from first MSc. Muvengal from first MSc. Kanchana Devi from first MSc. Jayashree from first MSc. Sasikala from first MSc. Yuvaraj from first MSc. Prabhakar from first MSc. Ashwini from first MSc. Ricky from first MSc. Rahul Kumar from first MSc. Charugesh from first MSc. Leelavati from first MSc. Hepzibah Shalli from first MSc. Bhuvanesh from second MSc. Jay Bharati from second MSc. And Danusha from second MSc. Thank you, sir. Volunteering is rewarding work. We will forever be proud and grateful to have such generous and hardworking volunteers in our department. As a token of appreciation, I like to call Mr. Bharat of 2nd MSc to receive the memento. Secretary of Brahmaganit Club. Mr. Shanmuganathan from 3rd BSc Mathematics, Joint Secretary. And Ms. Krishnana Devi of 3rd BSc Mathematics, Joint Secretary. Thank you, sir. Now I like to present the report of the two-day International Conference on Applied Mathematics and Computing, ICAMC 2023. So 2 days International Conference on Applied Mathematics and Computing was organized by the Department of Mathematics in the premises of DDGD Vaishnav College on February 27th, 28th, 2023. The objective of the conference was to provide an excellent national forum for academicians and researchers around the world to present their researches and to exchange ideas on recent development in applied mathematics and computing. On the first day, the conference was inaugurated with a college song and Nightingale's Dwaraka. Welcome address was given by the head of the department, Professor R. Venkatramanan, and presidential address was given by Dr. S. Santosh Babu, Principal, DDGD Vaishnav College. The chief guest, Professor B. Ravindran, Director, IMSC, explained about the theme of the conference. Keynote speaker, Dr. Pradeep G. Siddeshwar, Senior Professor, School of Sciences, Christ University, Bengaluru, lauded the department for conducting such conferences and asked the students to utilize the opportunity. In the technical session, 4 parallel assemblies were conducted in 2 auditoriums. There were 15 invited speakers in this 2-day conference. The eminent speakers from esteemed institution gave the talk about the applied mathematics and computing. Dr. Pradeep G. Siddeshwar from Christ University, Dr. S. Dharmaraja, Professor, Department of Mathematics, IIT Delhi, Dr. Usha Mohan, Department of Management Studies, IIT Chennai, Dr. G. Brito Antony, Department of Mathematics, Sacred Heart College, Tirupattur, Dr. K. A. Venkatesh, Dean and Professor, Chanakya University, Bengaluru, Dr. Natesan Srinivasan, Indian Institute of Technology, Guwahati, Dr. Bhaskaran Ramachandran, Professor of Department of Computer Science, Anna University, Dr. Madhumandal Pal, University and Nodal Officer in the Department of Applied Mathematics with Oceanology and Computer Programming, Vidyasagar University, West Bengal, Dr. Lakshmi, Research Expert from Chile, Dr. Nagapan Govindrajan, Head, Savita Engineering College, Chennai, Dr. Sunil Matthew, Assistant Professor, National Institute of Technology, Calicut, Dr. Vidyottama Jain, Associate Professor, Department of Data Science and Analytics, Central University, Rajasthan, Dr. D. Robinson, Associate Professor and Head, Madras Christian College, Chennai, and Professor B. Saravanan, Vice Principal, Faculty of Science and Humanities, SRM Institute of Science and Technology, Ramapuram, Chennai. So the invited talks were followed by the parallel paper reading sessions, and 46 papers was presented on the first day and the second day in the hybrid mode. Many participants presented their research articles and represented in various disciplines of mathematics and computing. Dr. Arjunan, Associate Professor, Dr. Madhivanan, Associate Professor, Satyabama University, Dr. Stella, Assistant Professor, QMC, Dr. Minirani, Associate Professor, Dr. P. Usha, Assistant Professor, DG Vaishnav College, Dr. Sivaraman, Associate Professor, DG Vaishnav College, Dr. Vidyottama Jain, Associate Professor, Central University, Dr. K. A. Venkatesh, Dean and Professor, Chanakya University, chaired the paper presentation session in the hybrid mode. Research scholars and PG students from various city colleges have attended the program, and PG students of our college also presented the papers. Most of the papers presented in the conference met with the theme of the conference and were of good quality. The presented paper will be reviewed by the review board, and the suggested paper will be forwarded for the Scopus Index and UGC CAR journal publication. The certificates were also distributed to the participants, and more than 200 participants have registered for this conference. And many positive feedback was shared by the participants, and in the valedictory address, Dr. K. A. Venkatesh, Director, Chanakya University, Bengaluru, have lauded the department and gave many suggestions. Thank you, sir. So I now invite Dr. S. Hariharan, PG and Research, Department of Mathematics, to give the vote of thanks.
Jai Shri Krishna. Good afternoon to all. It gives me an immense pleasure to deliver vote of thanks of the two-day event, International Conference on Applied Mathematics and Computing, ICAMC 2023, to all dignitaries assembled here. First of all, I would like to thank the Almighty for making this event happen. I sincerely thank our Secretary, Dr. Ashok Kumar Mundraji, and our beloved Principal of Dwaraka Goverdhan Vaishnav College for their valuable suggestions and constant support. Thank you, sir. I thank the Chief Guest of this event, Dr. B. Ravindran, Professor and Director IMSc Chennai, who honored this event with his inspirational thoughts. I would like to thank the keynote speaker, Dr. Pradeep G. Shideshwar, Senior Professor, School of Sciences, Christ University, Bangalore, for his valuable speech. I thank all the invited speakers, starting with Dr. Pradeep G. Shideshwar, Christ University, Bangalore, Dr. K. A. Venkatesh, Dean and Professor, School of Mathematics, Natural Sciences, Chanakya University, Bangalore, Dr. S. Dharmaraja, Professor, IIT Delhi, Dr. Nateshan Srinivasan, IIT Guwahati, Dr. Usha Mohan from IIT Chennai, and Professor Bhaskaran Ramachandran from Anna University, Dr. G. Victor Anthony Xavier, Sacred Heart College, Tirupattur, Dr. Madhumangal Paul, Professor, Vidyasagar University, Midnapur, Dr. Lakshmi from Institute de Alto Investigation, Seda Esmeralda, University de Tarapaka, Chile, Dr. Vidyodhuma Jain from Central University of Rajasthan, Dr. Nagapun Govindrajan from Savita Engineering College, Dr. T. Robinson from Madras Christian College, Chennai, Dr. Sunil Matthew from NIT Calicut, Professor Saravanan from SRM Institute of Science and Technology, Ramapuram, Chennai. I thank all the speakers who spent their valuable time and put their effort to come all over here and deliver their lecture for the benefit of the students, research scholars, and faculties from various institutes. Thank you all for coming over here, sir. And I also thank the paper presentation session chairs, both in online and offline mode, Dr. K. A. Venkatesh, Dr. Vidyotama Jain, Dr. Arjunan, Dr. Madhivanan, Dr. Stella, Dr. Minirani, Dr. Shivaraman, and Dr. P. Usha, who gave their valuable comments and suggestions to the presenters. I thank our HOD and Controller of Examination of DDGD Vaishnav College, Professor R. Venkatramanan, who drove this entire event and made it a grand success. I thank all my faculty colleagues who worked behind this event. I also thank all the participants, volunteers, support staff, administrative office staffs, and last but not the least, our beloved audience who made this event a grand success. I once again thank you all. Thank you so much.
Thank you, sir. I now request everyone to rise for the national anthem.
Subhanahu